Yes. And at the end of the day, we're able to see the
Okay, good morning. Can you please have it morning? Thanks for coming. Still some more people awaited. Okay. First, I will show the agenda what is today. So 9:30 is supposed to start. There is 10 minutes delay. We will cope up this. So 9:30 to 11, Mr. Pankaj and team, they are from Malapur. So just stay here and 5 minutes they will join here. We have tea break. And Sundar will give you a presentation on he's a consultant. He's in geophysics and also a consultant. 12:31 we will have question and answer. 1 to 2 is the lunch break. 2:45 Amrata, which I worked in Kuwait. So it is also there is facade is very predominant. So I will give it detail thing for you about that project which will help you. And 2:45 Mr. Mahesh is our facade regional facade consultant. He will be giving the design types of facade and everything. Then that is a small feedback. So 4:15 to 4:45, I will talk about the test. What are the tests required for the facade? Then any clarifications, we may have some small tests. So be quite vigilant. There will be a test. I'm planning to do the test. So the mark will be sent to best. Anytime we can do it also in picture. So you can inform your site team to please attend it right now. They can already share it. I share you all also. So ask them to make a little bit out of it. So we will try to close everything by 5:30. So we can and the keep your phone silent. Even the sound, everything also going to be recorded. You record it for the Okay, correct. Yeah. Okay, from there not anything. They're not talking. can start.
Yeah, please. Start your team. Yeah.
Yeah, here actually here talking of all this.
Oh.
The people not come right. So all the sites here getting through YouTube and also Skype.
Right. Good morning and welcome all.
Good morning.
On behalf of L&W, I think we are gathered here to understand the law of the start. Special thanks to Mr. Pankaj Keshwani and the team, Mr. Rajan Nagaraj, and Mr. Bobby, Asian Plan. A special thanks because all the way you have come all the way to help us understand better on this subject. That is sparing your valuable time. Yeah, yes, we are keen to understand from you. I understand that all of it started way back in 1984. I think more than 3+ decades of experience in this business. Initially, I started with those subsequently moved on to external research, and today you are the leader in the industry. We welcome you once again for your time. Thank you. I think let us enjoy the program with more interactive sessions with personal answers, better understanding. I think it will enhance and enrich our knowledge base. I think we can improve from here on. Yeah, thank you once again. Welcome.
Good morning, everybody. Big thanks to L&W for inviting us, giving us this opportunity to make a presentation. We have a presentation in 3 parts. The first presentation will be done by Mr. Pankaj Keshwani on the facade presentation, followed by Mr. Rangarajan on the facade design, and by me for the project initiation and execution. This is the introduction to the team. This is the managing director, Mr. Pankaj Keshwani, the GM design, Mr. Rangarajan, and myself, agent planning. And we planned this in this slot. The first half an hour by Mr. Pankaj, and the next half an hour by Mr. Rangarajan design, and the next 15 minutes and the last 15 minutes for the question and answer session.
Morning, everybody. Good morning, everybody. Everyone's woken up? Fresh? Yeah? Good. Okay, so what we're going to do is, we discussed, we're going to break it up into 3 parts. First, it's going to be a little introduction, what curtain wall is about, and how curtain wall came to be formed, when it started, and how it's now being installed in various buildings and projects, and what is the role of the curtain wall, what is your role in it. So this entire exercise has been done at the initiation of Mr. Asai, and I think it's a laudable effort taken by him and initiated from his side. Because what really happens is that right now, although we've been in this business for over 3 decades, there's not been a proper interaction between the people who are actually getting the work done at this time and we who are installing. So we are literally on 2 different ends of the spectrum. What we need, you don't understand. What you wanted of us, we don't, react in time, right? So there's a gap that's there, and this exercise is being taken up today to bridge that gap, right? To help you understand our problems and for us to understand yours, because then only we'll get closer and problems can be mitigated and things can be done in a better and smoother manner and get finished much quicker and faster than what is being done right now. Because that's the aim of everybody. Finish your building, move out, hand it over to the client, move to the next. And there's no point in being there for another 6 months when it's not required. So that's the idea. And with that in mind, this is what me and my team are going to be presenting to you today. And we'll take it forward from here. So I'll start with the first slide actually on curtain wall. So as you can see, the first curtain wall was designed almost 90 years ago by a German architect. And the very meaning of curtain wall is, you're really talking about a wall of aluminum and glass. So what's a curtain wall? That's why the name came about. Right? Because you're putting up the structure with aluminum and you're putting glass and you're preventing rain, heat, anything from coming in. So it's like a wall. Conventionally, when you construct buildings, you've got brick and mortar and then you have a window there. So since this is going to be sheer aluminum and glass, it was called a curtain wall. That's how the word curtain wall got coined. And this is what he designed, way back, like I said, 90 years ago. Yeah, just show the next slides. This was the gentleman, and that was how the first structure was done. You still see buildings like these being carried out. This is what we call the stick system. So there are basically three types of curtain walls. The first is what is the stick system, which was the first model that was done, which is this one. The next is the semi-unitized, and the third is the unitized. So just to explain to you the different types and what it is. The stick system, put the first type. Yeah. So this one, what happens is, you see on some buildings, especially on the outskirts of Bangalore or outskirts of any big city, when you're going towards official towns, you see that somebody wants to they're doing a bank, making a building, right? And you just get a local contractor and put aluminum sections vertically, they get it fixed together, and then they buy glass from some local dealer there and come and put it up there. And then it's not heat strengthened glass, it's not laminated, it's nothing, it's just simple colored glass. Whatever is available, they don't look at whether it's got any performance values or anything in it, it's just put up there. And then this building gets done. This is how it was done in the old, the first curtain wall. And it's what's being done also right now, but in smaller towns, not in the big cities. Right? This then graduated to the semi-unitized curtain wall. Right? And in this semi-unitized, what happens is that even now we have buildings being done like this, and so do we do it. It's a combination between semi-unitized and unitized, depending on the project specific. When you have a huge area, like what we did at some of your projects, like RMC or Qualcomm, or Globe, we're doing now at IK, these are all examples of unitized curtain wall. Because you have huge expanses and you have huge areas which you need to clad with aluminum and glass. In the other places where you have, a large, like I said, regular big mortar and with small openings, it's not advisable to go in for a unitized because you can't really put those panels and then come in the crane and then move each time because there's a lot of time loss. So you just come specifically, put your window, and in the semi-unitized, what happens is that the frame is done at the site, is installed at the site, but the panel is made in the factory. So the panel comes glazed with glass, comes over to the site, and it's installed there. Right? So that's what happens in the semi-unitized. It's not a unitized. In the unitized, the full panel with the glass comes from the factory. There's nothing done on the site except installation. So you put the aluminum framework, you do it. We'll show you some slides, and as we go along, we'll understand that better, but just to give you a little idea. The frame is assembled, the glass is put in position, the openables are put wherever required, flashing is done, standard installation is put, and then it comes to the site of the completely assembled unit and gets installed. So that's why you see sometimes, 30, 40 panels being done a day. You come one day, there's nothing on the building. You pass by that building 2 days later, you see the whole floor over, right? Because these are all panels that are ready and brought in, right? Unlike in a semi-unitized, you find work going on for 2 months, they're doing framework, joinery. Then later on, they'll come with the panels and then they'll start putting it in a position. So there are advantages and disadvantages. We'll come to it a little later. So this is just the illustration right now. So this is what I was talking about, the unitized curtain wall. The entire frame, for example, you have a 4 meter height, flow as you keep going along, 4 meters, 4050 is your floor height. And your widths can vary between 1, 1.2, 1.5, 2 meters, depending on what your design is. So you make this entire frame in the factory. What you see behind your slabs, what you do, your construction practice and put in position, this comes and it's anchored onto the building. these are various examples of tall structures and big buildings that happened years ago, right? Not necessarily with unitized curtain wall, but these are the models of buildings which stand the test of time and testimony, right? So we did just a few slides of those buildings. And what we're really trying to demonstrate from now, this is a curtain wall, a unitized curtain wall that was done at CS Towers. Right? This is the Petronas, again, another example of a unitized curtain wall. 101 in Devon, unitized curtain wall. Shanghai Financial Center, beautiful project, fully unitized. The One World Trade Center. This is Burj, everybody knows about it, it's the tallest structure in the world. And this is when we come closer home, these are the structures that we have. So what's being done in Mumbai, many of you may have seen it, those who haven't, here's an image. This is a 170 floor story, 442 meters high. It's not a unitized curtain wall, it's got cladding and it's got doors and windows, but floor to ceiling. It's a slightly different kind of concept. But these are tall structures, these are what are coming to India. We're doing many projects now. You will be associated with some of them where you're doing these tall structures. So just an example to show you that. Next. These are till now, till the 117th story gets commissioned. This is the tallest structure today in Mumbai. This is a 60-story at the Beetle House. That was built about maybe 7 or 8 years ago. This is very much closer at home. This was done on a stick system project, right? Not really advisable because when you go on higher floors, it's very important that you do it the right way. And what happens in a stick? Well, it's cost effective. It's not really a very good system because don't forget you're actually putting glass on the outside. And when you're putting glass without a frame, at least a semi-retired would have been better. In glass, when it's done from the outside, what you're doing is that you're cleaning the surface with some diary, with some solution, right? Then you put your spacer there, then you put in your glass, and then you're doing your silicone application. So there's a lot of contamination. The reason of doing it in a factory is that you do it in a controlled space, you do it within the plant under controlled conditions, so there's no contamination. So when you're working inside, you don't know how, you could be putting the labor, the workers could be cleaning in 1 minute, after 20 minutes putting the spacer tape, then coming and doing, and meanwhile a lot of dust settles on it, and you have problems. And then you have issues where the glass would then fall off sometimes, right? You have these crazy cases that happen, right? And these are incidents which happen when there was a stick curtain. So it's not the right method, and it's kind of done away with right now. But yeah, some people do it, and this is one example of that. This is what's coming up in Bangalore. This is going to be the tallest structure there. This is in Chennai, it's the tallest building, 50 floors high. This was in Gurgaon in Delhi. This is the project that we were associated with. We did this till the Victory Valley comes up. This is so far the tallest structure. This is coming up with Calcutta, as you can see. Hyderabad, this would be the tallest. And this is one building in Mumbai, which is going to be completely structurally glazed, unitized curtain wall. And this is a building that we're doing right now in Mumbai. There are 66 floors. That's going to be the tallest residential structurally glazed facade in the country. Work is just about starting our work rather. The building is right now on the 30th floor. Every 10 days we're casting the slab. They're trying to make it every 7 days. And this is going to be planned for completion is March 2018. Or it might get delayed by 2 months because they're waiting for some clearances right now. So as of now, in Mumbai there are some different rules and regulations. So they're supposed to get a clearance by 1st of April. It's likely delayed. They're expecting it now at the 25th. Once that happens, then they will then go forward. But It's got 11,477 panels, the 66-story building. The other one has 9,000 panels. So that's the kind of speed and time in which this is going to get completed. So I think with this, we've kind of given the introduction. Yeah. No, I like to talk about it. We can show it towards the end. I'll talk to you a little bit about the top-down construction model that we have done, right? Because probably that will interest you. Today or tomorrow, you have a project of that nature, but I'll keep that towards the end. Like the first focus on our issues that are there. Time probably will go to the detail more. Okay, so now coming to our specific works at the site. What's very important is that the sequence of work and how it's done. So very often you find that we have issues. We make a plan. How does the project of this nature get executed? And most of you are on the project side, so I don't need to go into too much of lengthy detail. But what happens is that the job is awarded. Right? Once that's done, the next stage is we get into shop drawing and we make a plan, and we have a kickoff meeting. These are things that happen parallel. So when you have a kickoff meeting, in that kickoff meeting, it's scheduled. This is the day from when we start shop drawing. This is the time when your civil work will get completed, and you give us a schedule. And you say, this is when this lab will be over, this is when you can start doing the survey, this is when you can start putting your brackets, this is when we start putting work, material of the building. And this is the timeline that we have, 6 months, 8 months, 9 months, whatever, from start to finish. And that's how we need to go about it. Now, what's very important is that for both of us to work together and to have a proper understanding, is that you honor your dates, we honor our dates. But what invariably, like I said, issues come up, right? Like I just said, we're working on this project for ICC. We're expecting some clearance that happen, so the overall date is going to get delayed by 2 months. But when we go back to the client and we say, listen, this is going to take 2 months, they say, no. Put more people, do what you want, get another 100 guys, you do it. You're unfit, you should do it. You have manpower, stop something, come here, do it. Now, I think that's a very, unfair kind of thing to do, because what happens is that, we're not creating people out of a factory or a workshop. They don't start coming out. In fact, this is one industry which you have to train people and get them to your way of thinking and then get them to work. And after you do that, they leave you and go somewhere else. You have greener pastures, right? So it's the most difficult industry to actually get people to your way of thinking. When you have hundreds of colleges that bring out civil engineers, mechanical, electrical, but there's no college that brings out a curtain wall engineer. Right? So just for you to understand how difficult it is to get it, where there's no school like an ITI or somewhere where these people can go, get trained, you get workers who understand the sequence of work and how they should do it. So what happens when you say put 50 more people? What do? Right? You're just going to pick up some clown and say, listen, come, you also come, you also come, you also come, because the client is counting how many heads are in the building, right? And that's not really the right way to do it. So I think what's important is that you, as the, as the between, let's say between us and the client, or when you are the end client, like in these cases, must understand the pain and the problems of the other vendor. So either you have to present it in such a manner that we will be 2 months behind because of these reasons. Right? The reasons could be so many. It could be you haven't got the clearance from, let's say, the authorities, building authorities to construct for more than so many floors you cannot go. It could be sometimes you hit rock, you hit there's rain, there's unseasonal rain. I mean, you were expecting it for 2 months, but 3 months you could work at that place. The whole place was filled up. So when these are there, I think what's important is that if you understand that these dates need to be also, that when a program is made and if 40 days have been allotted for an activity, you have given it 10 days later, you need to add the extra 10 days for the activity. And I think that's where the understanding will probably come. Yeah, we all work faster, we all work to try and minimize that, but this one thing sometimes doesn't go across. That's one. The second is that as project managers and as supervisors and as engineers at the site, you have teams, you have people, you have workers who are working there, right? And when we all talk about construction tolerances, right, you also need to work based on it. We talk about, you know, you're going up 30 floors high, we shouldn't have it more than, let's say, 15 mm. With 50 floors high, 25 mm. That's the tolerance and that's how you need to do, because that's when you get the perfection, even when we have to come and do it. But you go to a 10-story high building and you find out by 17. Now why is that? Because we've had buildings that are even 150 mm. So either the supervision or the quality of work that's being done by the people there is not done right. And we are not doing our job by pulling them up and correcting it and getting it done. So I think if this is an area which again needs a lot of introspection. You need to push your team, you need to get your guys, you need to have control that you're in and check as to what level, what is it that you're giving. Because the better that you give us, the faster that we can do. So if, for example, the survey comes out correct, we can make all the brackets on one side, bring it all together. We always allow 20, 25 mm tolerance, the bracket will take care. But you've got 60 mm, right? Those areas have to be specially fabricated, new brackets have to come, different locations have to be handled. All these create problems, create delays, you know, bring across there. So thickness has to be changed. The moment I'm bringing it out by 70 mm out of the slab, it's not resting on it. So I can't use a 10 mm plate. I now need to use a 12 or a 14. Calculations have to be redone. So these are areas which you can help in making things faster and better. Right? So we're talking this because we're looking at a coordination how you can help or we can help. Right? So this is another area which we talk about sequencing, works that need to happen, right? We'll show you slides of how to avoid damage and what we mean by damage to panels and what shouldn't happen. I'm not saying it's happened at your site, but it's happened at other sites of ours. And just I'm going live to you know, your other engineers in different cities. They should also understand what's happening, and if there are areas of concerns like these, maybe they can address it at their end. And, you know, but it's helpful tomorrow because you never know how work gets done. We'll share these slides with you so that you get to understand this better or what you need to do later. So this is like cleaning, so that, you know, when you put, you would then tomorrow after the building's handed over, give it to a maintenance agency, they'll be coming, they'll be maintaining it, how they should maintain it, what they should do, what they shouldn't do. So these are some things that you can make a point and note of. Right? Now this is what I was saying. This is actually a finished product that we've done on building. So what happens is that because of ensuring the speed, right, everybody says, you don't worry. You will stop. My responsibility. Anything goes wrong, we change it. We replace it. It's our cost. But you put the glass, you put the aluminum. Because you are under pressure from the client, he wants to sit over so that he has to do his interiors, he needs to finish, and things have to happen. Now, we're ready to work, we are happy to do it. All we're saying is, please provide protection. So you can just see the amount of damage that's done the aluminum framework. This is what happens when RQC people go in, and this is actually their report. Confidence managers observe the glass dismantle. Alright, so unwanted bulk works and layers. So that kind of thing. So this is, look at another slide. This open window station is stored, handles put in position, but this is how it's being done. Because what happens is that during a strict window, so we've asked you for an opening. When I said you, I mean civil vendor aside, it was an opening. You asked for the drawing, 6 meters by 1.8 meters. You come to the side, it's 1.85 meters. Right? This is not we do it, we come and fill it up. Leave the gap on the top. You come, you start putting it on the top, and the whole thing's falling below. So no one's there to supervise, no one's there to check and say, and then we can't be policemen. We've done what you asked us to do, but this is the state of the material area. This is the case in one project side. But actually, Our panels are stored below, right? But the bucket opened on top, when they were moving cement. So the entire slurry fell onto our panels and was stashed below. That's another one. But you don't have more of those ones. That is particularly. Okay, you got it. Okay, so then I'll explain this. What happened here was that over 100 panels that were below got completely soiled, and the client ended up spending 50 lakhs more to have them replaced.
You got protected when you stash the panels below.
What happens is that you are stashing it below to be stored now. These are stored and kept there, right? So you're going to now start work on the building. And where workers are down, it was actually an accident that happened, right? So otherwise, it could have fallen on someone's head, right? People could have died. Now, what protection I'm going to do if you put a tarpaulin over it? The guy's going to die. He's going to get submerged under it.
Okay, that's an accident. I understand.
Yeah.
When you're stacking things, you.
So what we do is we bring it into a pallet frame, we unload, we bring it. Now, this 50 pallets have to be put on that day. But I brought it, it's a 24-hour operation.
So you
I'm standing, my label is here, wanting to take it out. So this, what you need to really do is that you don't have to be transporting material in day. So you're moving material from one end to the other without taking care of what is below and what's stored below. Because of the speed and time that you need, you want to do everything together. So that's what happens. So either you must have a dedicated store yard which is kept where nothing comes in. There. Right. Now we done our flashing. Yeah, okay, you can see that. You can see the name also who's there. Who's the silver connector, but let's not get into specifics, right? We've actually put the speed support onto our flashing. What kind of protection can I give? He's taken one support on the top, he's put another scaffolding support through the gap. Opening, you say install it, it's our problem to do it and close it. So what we're trying to tell you is that the more you're conscious that this is a finished item, this is a material that cannot be retouched up, can be finished later, right? The more you will get a better finish on the building. Saying, are not as good as what you have in Europe or in Singapore or Malaysia. The care and the attention to detail that's given there. There's a conscious effort not to damage the other man's material. Approach. Mera kaam ho gaya, tu jaan bhar. Okay? So that's the problem. But unless we start empathizing with the other person, right, it's not going to happen. We've done the rock wool insulation between the floors, right? It's already done. Someone yeah, that's what.
Okay, somebody has put
Insulation. Yeah.
support for the fashion.
Yeah. See, that's it. You don't put it to support the flashing. Right? Okay. And taken other support at the top, and one scaffolding through it, and he's taken that and he's plastering the opening with it. So what have you done really with my aluminum frame? You just taken it, just smashed it like this. So you've taken out all the other area and all the powder coating also along with it. And I'll show you slides a little later how material leaves our factory and how it comes. And then you see how it's actually installed. So there are ways and means of checking this. All I'm saying is, what you really need to do is, these openings need to be, if you're doing this, give us the right opening. What we really, like I said, this is a dialogue. This is not a fault finding mission, because then I wouldn't be here. So it's a dialogue. It's to say how I can do better with your support. That's the aim of this meeting. And what you need to take care of. Because Mr. Asai and we were discussing and tell them my problems. This is what happens on the site. This is what he said. I want you to talk to my team, and I want them to understand because they're the people who are actually on the project side. They're getting work executed. And with that, he said, I will have a conducted workshop only on. And that's how today I'm here, and I guess we have most people later today. We're going to be talking about the challenges that we have and in what way we can make that better and make your project look more better and finished. Right? We don't want to be like the other contractor. There's no change between you and the other one. You're like here because you're making a conscious effort to learn. That's the aim of this exercise. So I'm saying let's not have situations like this tomorrow. You can make the openings right. You can put a protection cover on the top when we are working from below. There are project sites where we've done that also. I'll show you examples of a good finished facade. Yeah, show them how to dispatch. I want to show that that building where we have the overhead protection. So this is an example of a good overhead protection. The overhead protection is done on the 8th floor. This we done. This is a building in Bangalore. I can take the name was this was Cisco that we done Cessna Business Park. We contracted with JMC. And when we started our glazing, we started from below. We wanted a protection. They had work going on the top, but no slurry fell. Nothing came below. We finished them down. Did the smoke seal, did the flashing, closed everything, and it was done. So even here we can do things. If you are interested in doing it, we have the right approach, and you want to do a nice job, we can do it. That's not possible. So you can see we finished windows, we finished everything. It's all closed. There's nothing, no problem, nothing is damaged anywhere.
What kind of platform it is?
It's basically go back to it. Yeah. So basically, you can see that the steel members I section are running out. They've put a GI sheet over it, and that's what's covered. They've taken a little bit of the inside with this anchor below, so that if anyone steps over it, it doesn't just drop it. So this is some other areas of protection that are done on the site. Okay, so to answer your query, I didn't get your name here. Abhijit. Okay. Abhijit, this is how the panels leave our factory. Okay. So you can see the care that's taken in handling. Panels are finished, glazed, then moved in a forklift from one end to the other within the plant. Then they come onto a steel pallet where it's packed. And protection, everything. But when I have to install, we need to remove everything. Okay, so yeah, we unpack it once we bring it to the site. You see the pallets then have to go back to bring the next lot of material. We unstack the pallet. Can't provide for every scenario. Typical pallet. And then they get unloaded on the side. These are how they're loaded into the truck before they leave for the various sites. And then unloads the pallets. Then they are lifted and taken to the site. Now they're taken up to the unloading platform where it comes in from. It's taken there, and that's how this is a project in Mumbai that we did for Golden BKC and Bangalore complex. And it was a 22-story high tower, and we had unloading platform at various floors. Depending on every 4 floors or 3 floors, we had a platform. We bring it and take it there, stash the panel, and then lift it there and install. flow plate that's there. So if you have a large number of panels, then it's advisable to keep it on the respective floor and then do it, because how many can be stored below?
They say they take it and install it immediately. You don't need to start.
No, what happens is that you do it in your flow plate and your hoist is lifted and you install it. That's true. But you have, let's say now, project an eye gate that we're doing now in Mumbai for you. You've got 4,700 panels. Right? And so your flow, based on the flow plate, we have something like 500 panels of flow. And what happens is that it's an L-shaped block 5 and block 6. And you have so many panels that if I'm going to do one floor, right, I can't be stashing everything below because I'll be using so much of surface area and space. So it's ideally best that we take it to the respective floor and then at the floor we handle it and do it. We're doing it at all the project sites.
It's a double handling.
Sorry?
It's a double handling. You're double handling.
Yeah, it's not double handling, we're taking it for the floor. Really. Aren't we doing the same thing at global sites also? We're doing it like I'm taking it. Yeah, there are 3 blocks. There is wing A, B, and C. Each wing, they're all typical. They're ground plus 10 stories. That's also about 5,500 panels. And each floor, each wing is 173 panels. So what we do is that we make it floor-wise. We bring it into the site, stack it there, and then we take it to install. Okay, I think, okay, so just to summarize what I just spoke to you, like I said, there's a role of ours and there's a role of yours that has to be done. In our role, what we need to ensure is that the dates that you give us and the timeline that you tell us to do the job that we adhere to. Right? There are issues that our end do. I'm not saying that we are these have to be signed off, these have to be closed, then only we can go ahead and start production. And we have challenges, like in your industry, you've got rain because you're working outside, you've got soil, you've got other issues. We have challenges because we have 30 different components that go into making an item. You have a vertical, you have a multi-different transform, you have a transform, still, 25 different dyes, you have glass, with silicon, you have spacer tape, insulation, your sheets, and unless all these various components come together, your panel is not complete. So there are challenges, and there are delays that happen. But what we need to do is that we understand each other. You give us time, we work towards that time. Structure as to what's expected out of you, and we have to deliver to you the goods within the time that you want. So that's basically is how we can work together and move closely. And I'll just show you but if you're interested, so would you like to see it?
Yeah.
Please. Sure. And then the team will talk about design and the rest. Technically, we're not supposed to give the name of the building, so we just call it a Fortune 50 company because it's confidential. So, but you all know being in Bangalore, this is the general thing. So, this was basically the concept of the drawing board, how it got designed. This was done in New York by Strong Constructions. We had a team who sat down in this planning from the beginning, from the starting stage itself. So it's actually part of our team. You'll see that next. The other Chandra and Mohanty. Both of these are designed. And Chandra, as most of you would have known, is up today. architects in charge. We have vice president of architects. Very dynamic person. And so this is our the project, how it was envisaged. And because it was a top-down construction, it was important that everything was well planned. It had to work like a well-oiled machine, you could say. So all the components, all the aspects had to be done. Because there were only 16 days that was there from start to finish, finishing a floor. That meant, concreting, steel, aluminum glazing, and lifting it to the top. So what really started out was that there were several cores that were constructed first. And these cores were done in a matter of 3 months. So there are the service cores that are there in the building. And the building is one working the design. There's Gerald, who was the plant in charge, and Kusu, who was where and that's always our money. He looks after the bill of materials, and always looks after the procurement. So what we did was that before we actually started work on this building, because we knew the challenges that were there, I took the whole team to site first, and I said, I want each of you to understand and analyze from your aspect what you could probably face in terms of the challenge tomorrow. Because we can't installing 238 panels on this building. Within 6 days, we have to see that everything is right and every component is available much before the today. So that's how we worked around this project, because there was no floor, so to speak. That's how we did it. So we first came, everybody thought about it, and Ranga joined us later, so let's see none of this order. Ranga, now let's design, come up with the reports to. So this is how the steel structure was put up first. And this was what we call the sheet. Heavy sheet. The heavy sheet, like the sheet. Yeah. Bars. And they're concreted. Yeah. So the initial plan was that everything is to be finished as a floor, including the fire safety below. So all that painting was all done. As you can see, this is the underside. They realized that there was a lot of sway and swing, so brought it down. First time we had a little challenge there, and then we removed that. So they only did it, and later on they would finish the fire safety there. However, in phase 2, which we're now going to do, they found a method in which they will finish it with it and take it to the top. So those were the first 2 panels that went up, and it's how we were starting to put it on the building. So the first panel was in conventional buildings, what we do is that you construct and like I said, each day with a 16-day cycle. So less than 6 months. So we had them divided into wing A, wing B, and we had a knuckle. So what we now see is the knuckle being done. The knuckle had, I think, 38 panels, and the other 2 had 112 panels each. So together, this was odd panels. Building in different locations to pick it up. And as you see, it's now starting from the first floor level. So the first lift that was taking place, that's Anand was our project in charge, who's to Chandra's right, who's Chandra, this B, and this solution that you see. So you can see that everything was down below, but later on that was changed. So you can see it's going up. Now it's reached the top there. Just come down. So what we did was that this project had, along with the glazed panels, you also had a lower panel in front, basically as a shading device. The device was also installed at the bottom and lifted. We never used any gondolas of this building. We didn't need to. We didn't need any scaffolding. The whole building was just done without anything, because everything was installed at the bottom and was taken to the top. So this is how it's down on the top. So right now what you see, the knuckle is done, and soon you'll see other slides with the inside steel that we see are temporary supports that have been provided. The panels included and they were installed, and the supports were removed. So they lifted it with everything in place. You know, these slides you see, even the chiller that we picked up, even the other equipment, we was the one together on.
What is the size of the
Total built-up area was 7 lakh square feet, and this was spread over 10 floors. Ground plus 10, so you can say something like about 60,000 square feet of floors. So we also had some projections, as you can see, you know, some members in the front because they would move from bottom to the top. It was part of the design brief. Next. So here you see actually you have main the knuckle in position and main E and main B coming and merging right now. And this is how it's now come together. It looks like a high monorail. There's some trains going on top. That's the first large panel going up. So what you saw was the 10th floor, and now the 9th floor is happening. So this is done now in wing A. This will bring up the balance panels. We have this higher relevance. So now, like, because we can bring it in stacked or bring it back, but then there's a time we have to open up.
This is infrastructure resting on the metal core.
Yes. Which are glazing or the
Structure.
talking about the
Structure.
structure. Yeah, so like you saw that, okay, there's a technical thing and I'm not very familiar with it, but that was the thing that was arranged. So they had it at various locations, they had this hydraulic thing that was done. And they had to set, you know, align it to that degree. So they had a little window opening that was required with one slide. And then depending on the final alignment, they would kind of leave it at that stage. So even for us, what we did was in our design, we provided for a settlement. Right? So they wanted 45 mm, and they said let's keep another 20 mm because we're wrong sometimes. So our we have what's called a chicken head because one member gets into the other one, And that one has an allowance of 65 mm for, that in case the settlement, it's right now here. If it doesn't, 30, 35, whatever happens to be within that. Otherwise, you could probably just have glass breaking because it's putting pressure to it. So this will goes up and then reach to the next level. So how this will go up is that it should go hours, because you had to align it at each stage, so it would go 10 floors. And of course, as you came to the 9, 8, 7, 6, the time came down. So 8 hours was the tallest one. So every floor, initially we would go in and then we would align. And the last floor, when we would reach there, then every 111 we were kind of checking aligning because there would be a place, the one place, but that's where you needed to come and align it perfectly that kind of set. You can just keep these. So like I said, all the other materials which initially you planned to be done from below, now we started putting all the ducting on the floor and lifting it. So that you don't have to come down again, you can just take it there and so this is the other insulation material behind. You see there's a chiller right there, the orange color. It's all lifted together at one time.
So then support will be removed.
When you're lifting it to avoid the misalignment because there's no support while you're jacking and you're pulling it up. And then once it's all over, we're done with our job, it's removed, and the other agency is already working inside.
Once again, like that.
No further line. It's only when you're lifting it at the last level and that's when you finish it. Nothing more beyond. That's when those hydraulic things are then put in and aligned to that. So here you see there we have a flashing detail that's there. Between the concretized floor and our blade. And that's where we come with the rock pool, the GI flashing, which is here closer. So the advantage here is that as you finish, you can start finishing your interiors and other materials. So within a very short period of time, this building was handed over. So if you save 6 months, just saving 6 months of rent, you get 6 months more productivity, everything happens in this standard construction. Unitized is now starting to follow the model in all their projects all over the world. To tell you, this was the first time after 1970 that a top-down construction has been carried out. The first time was done by the same design team, Comanche, and the name was there, the structural consultants, Comanche. And they did the Russian consulate building in New York in 1970. Once it was designed, this gentleman then didn't do anything with that. He was a proprietary. He didn't share it with anyone. He joined another consultancy firm. It was, against the ethical rules that were there that you share this and you're working with someone else. So he then resigned or retired in 2005. Then he got down into working on this concept again. He was ready with this new technology by 2010, went and sold it to Intel, and Intel bought the rights. So that's what happened. So then they decided that they'll do their next construction when they were doing it in India, and so down in lockdown. Now the 7 lakh square feet is over, they're building another 7 lakh square feet right there, which is phase 4. So, and they plan to do it in Poland and various other countries, which they're now doing. In Israel also they will start work, and before it extends And not just 9 months for the other work, but even including the interiors. They will finish floor-wise.
Including the structure.
Including structure with the glass layer. Plus, I think the interiors along with it. So within about 2 months later, they were ready. Sorry?
Cost-wise.
Cost-wise was a little more expensive because I think all of us were working for the first time, so we didn't know what to anticipate and what to consider. And like I said, there were so many challenges, so
Again, to systems, plus the other person consider that we have actually, it's not that it's 5 to 6 times. Yeah, 30% more, let's say job glazing is 9,000, it's about 11,000. So it doesn't go up that drastically, maybe in construction and maybe
Only one floor is still there, can propel 2 floors.
no, 1 floor because that you are raising the floor and you are lifting the floor.
I can go.
Yeah, exactly. But then each of the cycle every 18 days. So 6 days we do a work, right? And that was the last part. While that time the floor would go up, the next floor would be
Including interior.
sorry,
Including interior.
including
Bigger.
no, not without a little longer. That's what I said. Just around these slides because this is so this is now, you see, we've now come down much more. There is the other floors, and it's just towards the end that we're reaching.
These glasses are low or
They're all low electricity for same domain glass, laminated with double glazed for stringent, higher performance glass. It was 8 mm plus 12 mm air gap plus 13.5 could be laminated glass on the inside.
So the facade was
It was deliberate. It's an incline. It's an incline.
it had nothing to do with the top.
No. It's designed like that. So as you can see, it's got an angular. It comes this way, it comes here, it comes down. So and it's going.
It looks like very overlap. One panel is going below the.
Yeah. Right. So that's the design intent. That's what we saw the model initially. That's what it was designed in the table. It was planned like that. So just like a 3D rendering, what they saw there is what they got. We covered, finished. I think I finished my part of the presentation. Maybe I took a little longer than required, but I'll come back to answer any questions that we have later. I'll speak on design and Coffee will talk about the logistics. How much time do we have?
You get it.
No problem. Sorry. Thank you. Thanks. Oh.
entire construction was a radiographic inspection. What is the lifting time for the
So the 8 hours.
8 hours?
The first thing took 24 hours because it was, like I said, went up, realized this ducting materials are falling, had to bring it down, remove everything, then take.
Okay, good morning. So my name is Unitized. I'm doing a design. And then I visited to associate with that project and about that the is coming up. So I will be associated with that. Like, I'm trying to utilize the importance of the design activities and the particular process which you need to take into consideration to meet your target and the project plan. Because what I have observed in India, because the date is fixed, the client is fixed the date, then you need to come. The facade is a lot of activities involved, a lot of coordination is involved. Okay, it's I request you. Okay, so I will explain here a few cases what we overcome with your project. Okay, which we are a little bit struggling, but at the end of the day, it's a challenge for us to give some solution, and the project is moving ahead now. Right. The moment the project is awarded to us, okay, there are a few things in our organization. We have internal kickoff meeting. Okay, we discuss about the project and contractually one another discuss all these points our commission manager will share to all the department heads. So we understand about the project very well. We give the architecture drawings and BOP and everything. Okay, sometimes we observe that the moment we start the board in our design office, I always send a mail to the client and the architect and requesting a final set of drawings. Okay, we observe that sometimes the drawings of elevation plans are not in line with them, or sometimes they updated elevation with the plan. So here we are really losing a lot of time. So definitely we should have a final set of GFC drawings. Okay, then it will help us to meet your target dates. That is important. If we give the information, I'm not saying L&W is giving like that. I'm just trying to see that there are the problems which we are coming across with other clients as well. Okay, to overcome this problem, I'm just putting the word in future projects. Your elevation plan and sections, everything is coordinated very well. It's good for all of us. Okay, instance here. Okay, this is the project I did your project we are working within now. So what we expect with the moment the project is started, we expect the updated applications and bit of confidence and structural slab drawings and PD drawings. So we understood that sometimes that the PD structural slab drawings are not coordinated with the architectural drawings. Okay, then the moment we draw that, we come across a lot of problems. In fact, in the project which you are entering with us now, we got a many problems with it. So really, it's a big challenge for us to handle. And finally, we are taking the decision to go ahead with a different type of bracket, different thickness, different number of anchors. So please understand this one. This will take a lot of time, lead time. Okay, they're putting the different brackets and in terms of fabrication, everything the time. At the end of the day, the time's adding on daily. So it's totally we come with a little bit unfair on that the scaling. Please coordinate this information because the structural, if you see the PV drawings and architectural drawings and the structural slab drawings, all the tenders are following in most of the many locations in the Mali. In fact, that should be laid out between the panels. So if the panels or architects are well designed about the panel mountation, we take it up at least in the middle, at the center of the panel. This is the reason why I'm telling why you please bring the vendor, facade vendor also in the beginning of the project. Okay, we always give a suggestions and solution. The moment in this project, even I remember that I was in Mumbai, okay, at the level 1, level 2. The moment we bring this attention to your management very well, unfortunately, some reasons it has been extended. So we are coming with a solution doing of number of brackets, different arrangement. So that is taking time. It's affecting us, it's affecting you as well. Okay. So that is one of the important points we are observing. Then all these items, bill of quantities and all, we have to identify what are the scope of activities. Okay. So these are the inputs are required for us to do the drawings. Right, and then the coordination process. Okay. Once we start the board or the drawings and everything, so we always have a design workshop. For this idea of I visited a couple of times your office and I met Mr. Sita. He's left from the organization. Okay. So the problem here in this project, there was a DSP architect was there in the project. If the architect was involved in my workshop, some more months and time on this project. On the board in the month of last week of Feb. Okay, we were working with L&W from the December last week. Okay, almost 4 months after they come and they have their point of view. They have their own point of view, what to do. Understand? So the architecture was the building was designed with them, you see. So it's for us, it's a challenge for us to convince everybody. And they love it.
Yeah.
So the design workshop I have come across with my project experience. It's really good. Give a good solution. On spot, we can take a decision and finalize the detail. We have done closely with Mr. Sivya. And of course, the meeting, and very frequently we always use the site visit to check all the things. So the outputs of this one, by workshop, by all the input documents and everything, the output finally we are getting it, short points and structure calculation. Okay. Right. The moment we finish the short points and structure calculation, normally we used to submit to for the client and architect for the review and approval validation. So they have to give the approval. They have to ensure that they go through the documents what we have done accordance to your project, what we have quantities or your project specs and everything we have done it also. Very important from the client side. Okay, sometimes I have seen in India that most of the projects are with the facade consultants are there. They have expertise on this facade, so they think always done. So in Nigeria, there is no facade vendor. Okay, so please ensure that this also approval process also very important. In future projects, if you don't have a facade vendor, we always require supporting documents. Okay, we should always have the drawings and documents calculation approval. Otherwise, our published policy, the quality team or ISO body will not allow us to execute the project. I'm emphasizing this point that the approval is important and calculations.
So we must have a facade consultant.
Yes, so some project they don't have the facade consultant, in that case the client. Okay, sorry. Like this is a few examples that we have here in our EV project. Okay, which definitely we must overcome this problem. Okay? See the bracket positioning it is going to the eccentricity or that. Normally this bracket we do from the width and it's standard, a bracket is standard. Okay, what happened in this project because of the PK lines are falling there, every cases. I just put one or two slides, there are more cases are here. So just two angles. This is our standard bracket, okay, which have the vertical slots there. We can have adjustment all these things. Standard detail for the finished floor level data is there. Okay, the installation is visible. Insulation is visible now, which is aluminum foil. Okay, there was a coordination meeting with your team that they asked us to remove the increase. There was a finish. Okay, please remove it. The time being is missing data. I prefer that you should have it there. But we can have always a detailed everything well coordinated. Now we have to find a way how we are going to cover the phone. I know, see, many of the familiar in this industry and facade industry are very. Is there anybody in the fresh completely new to the facade? Running through just doing most that's it. So all are familiar with the facade, right? So here the spectral properties and standards. The aluminum extrusions are normally we use alloy 6063. Okay, P6. Okay, we always have codes based on the project spec, whatever the code they refer, we will follow. This project is basically IS 8147. Very standards are there. Okay, whatever the project spec, we will follow the codes to analyze all that. And this is general for aluminum extrusions, all the module and brands alloy will be 6063 D6. For the bracket blade, which is going to carry the dead loads, okay, we always go for the higher alloy, the grade is 6005. The important we can't use the same as the extrusion of that because that is carrying the loads. There are a lot of properties. I just put the important things here. Aluminum extrusion. In my scheme, this is the IS 800. We use the grade 250. Whether the structural depends on the grade, we need a full 450, 550 sometimes. But in general, for our facade industry, we are using 250. And the standards and softwares we are using for loading for building, IS 875 designed for building and structures, and aluminum IS 8.47 specification for use aluminum alloy structures, and mine steel grade, and glass we use ASTM B1300 and AS1288 Australian standard as well. Used for structure calculation, stat pro, and rank cover because I know we have shared our stat files also the projects to your structural team. The objective of the structural report to identify and analyze all these things, the glass panels and aluminum framing, open framing, bracket connection, anchoring system. To analyze each and everything, the member of deciding the real size what is the depth we have to go for it based on the given window. Okay, for example, in this project, if you take I think 2 kp. Okay, depends upon the project we design in profile. Even sometimes we can minimize the profile where every slab should have a more thicker. For you, for us. Okay, this specifically I've taken idea project to get me. So I will analyze the aluminum profiles, ideas 8147, the codes recommendations. And that is the Unitized system. Basically, the pattern or the profile which you see there. Okay, because we always keep the water maximum in the first barrier. We always keep the waters outside. Take the water from there. It's not that the heating principle basically. The outside and inside of the building. Okay, the first barrier you see the detail. Then we always have a basket. We keep the water outside. We talk about that the first one is the red zone. One is the dry zone. Okay. The red zone area where the water will be there, this all water will be like a condensation water. So I'll just run much slide of the brackets installation video. See, pallets coming from the factory from the trailer. Okay, it's a steel pallet and it's lifting by the tower crane and loading in the. See the panels of stacked in the floor level. Take the panel from the inside of the building and install it. Yeah, this is one of the things I want to just explain to you. Maybe you have a casting channel. So now in this project, if you go on with the casting channel, no problems. If you go into the project, but still, it's a benefit for everybody. So you need to take one bracket and everything. You keep also to keep up your project still go faster installation. Showing the bracket adjustment in and out, how we can do it up and out.
What is the channel?
The casting channel is embedded in the concrete. The moment you do this reinforcement, the moment
there's so many brands.
there are so many brands are there. Okay, steel reinforcement concrete is there. Sometimes you take it in the cushion, exact as per the panel foundation. Normally the channel we use 300 to 350 mm long. Okay, either sometimes we do a banquet or sometimes we will tie it. Okay, so that all we will do it with a coordination with the contractor. Okay, then we go the concrete. Yeah, just we are good and very easy. In this case, if for example, you take a project, I get you avoid this proper wall PD tension cable and all this. So in that case, let's say the point 3 level. facade done at the beginning of the project, please. This is very, very important to do the efficient in design. Engineering, we can give a solution is good for both of us. Okay, so that presentation is over just for about the quick about the design process and about the coordination, what are the documents, inputs and outputs. Okay, so what is the validation and output, just big one. I'm not going to go into detail, just like outline and come. Because to save time as well. So next we go for another one slide. There are three topics. I think this is a big slide. So many slides are there. Just I ran through fast. Okay. System. Why facade system is required? How facade system is implemented? Okay. What is a facade system? See, facade system is basically an external envelope which covers the building. Okay, today you have seen that basically many the developer is just doing the slab and column, that's it. Please come and do the facade. Okay, it's a very easy and fast process in terms of aesthetic and quality, okay, performance, everything you get from the facade. So it has a great advantage of doing the the building with the external envelope. That's the point what is saying. And as far as the curtain wall is concerned, only the loads is taken by its own weight. Okay, the panel weight, that's it. There's other loads are not there other than the panels. Modern buildings exterior was suspended from the concrete floor and all this thing. Okay. I think I should not cover this. Sticks is just I can say. Anybody wants to know?
What's a double screen? You can show the image also. Double screen facade. We'll show you a double screen facade. Let's speak up a little.
See, the double screen facade is two lines of the facade. One is the glass one, and the second shade is sometimes they're doing the glass also. Sometimes they do like a perforated screen or like that. You have seen a project called an IDC, we are doing there. Study. Okay. There's a screen which is perforated, you have observer screen and vertical screen. Okay, which is gets in the solar and all the lights and everything. Okay. So the double screen facade building consists of two stages. There is saturated that react to the visual cavity. The ventilation of cavity can be natural, fan supported, mechanical, ventilation on.
We'll show you a little bit. Next slide.
So you have a image for that. So topic we share with the photography. This is just a drawing. Okay, the second image is all the screens actually. Now, regarding the Unitized system, actually, the structure glazing industry is the most superior one in the system because most of the projects we see today, everybody wants a Unitized system. It's because it is the panels can be made in a factory in a good environment, okay, and the quality in terms of quality and will be clean, and it's a finished product. It comes to the site and we can install the panel. And also the advantage of the Unitized panels. Okay, collapse the building movement, the structure movement due to the dead load, due to live load, seismic, and all. Okay, and thermal expansions, all will be taken care in the unitized practice. Then I believe that it is all you are familiar with that construction of the panels, right? You want me to explain about the panels, about male and female boolean? You want me to explain? You are familiar with that? You want to explain? Yes, sir. Yes. Just like one here, just typical pattern. Okay, normally the left hand side normally comes with a male boolean, right side with a female boolean. We call it as a technical terminology, right? And then this is the gate transom, and this is the intermediate transom, and this is seat transom. And this is standard emission. Standard is nothing but it's not visible area. It's not cheap. Okay. The emission is a visible area. Okay. Normally the generally it depends upon the project specs and requirements. Okay. So people will use typically everybody use a double class here, and here we use a single class to save the cost. Okay. Again, this all it's depends upon the project specification and your requirements. If you need a double class, of course we recommend a double class. So this is the typical pattern of unitized plan. Any question here? You see this panel, right? Yeah. So again, this is the vertical member, the boolean, female boolean, air transit, intermediate, and seal transit. This is the assembly of the whole panel. Of course, we have if you have the double class and single class, you want to same phase. We have to use some adapters to keep it on one phase. So that's basically here. The system of facade comes with the fact in the form of analysis, correct?
Sorry to disturb, but I wanted to understand why I didn't call it female boolean. Like, why is that terminology like that?
Right. See, that's a panels get an interlock basically. Okay, you see the shape of the profile.
Is it to do with the joinery?
See, there are two types of systems out there. In India, mostly they are using this kind of construction. A profile which like that. That's a main profile. For easy understanding for everybody, you know, to understand the plan. So they call it this one as a main, which gets interlock and connected at the time of assembly. So here these two profiles get into each assembly. Yeah.
So the section is like that.
Yes.
Okay.
So there is another system also available actually the both the sections. Normally that will be used in Europe. We call it as a smart system. Okay, then both the profiles are same. That has a different type of constructions. So that's like a squad it's okay. In this case, the both the profiles are same. Right. That is the way how the construction here which I am showing here. Each panel will have a male and female connected to the transom, air transom, gutter and water transom. The earlier video you all saw that how is the connections, how is the assembly, how is the gutter connections and everything. The glass will be factory case come to sign as a complete with steel brackets. Of course, along with that the bracket also will come, which is the panel. One part of the bracket will be with the structure. It's a prefix level structure. The second bracket will be fixed on the panel. They will bring it to the ground.
You can make it as site.
Sorry?
You can make it as site. Exactly.
This panels.
static glaze.
No, there's a two type of constructions or details what we want to the project. There are certain parameters we fix on the factory, and there's certain type of consolidated will be fixed on the site also.
Can you do the site?
Assuming the balance. Assuming the balance, see, normally the balance will be doing the factory is a controlled environment, right? So all the workers are working on the ground level on the floor. Okay, you will have a good quality, right? There won't be any scratches. You know, site, what is the condition of the site? Okay, it's difficult. We can't say that no, but definitely then again when you do the silicon structural bonding, you should maintain the temperature also. Temperature and the close area.
If you don't have time, because you have to take it to the factory and make it fabrication.
It is a mandatory. That's what again I'm emphasizing. Give the project in the beginning.
But it's not happening, you know.
Huh?
It's not happening.
It's not happening sense.
Everybody talks, but it's not happening really. Just telling, I'm not telling.
No, I understand. Not happening sense. What is that?
This is the practical decision that everybody says.
Okay.
See, what I'm telling you, you're talking about compound structure. If you plan the project in advance, no need to spend so much money. You can start with it properly and get it done. So everybody, I'm just telling you, it's not an argument. I'm saying that it is not happening in the industry. Everybody talks.
But that's why we are meeting today to spend
Yes.
But it's not only at the execution level. It's every client and consultant and the contractor and design.
No, that's right. So what happens is that the reason why they were not giving the contracts earlier is that everybody feels that if we give it too much earlier, then we have to share with the advance. You know, right? So let's wait. Anyway, there's time. Right? But what really happens, what you miss out on, is that actually, if you're finalizing the contract 6 months earlier, you're finalizing at prices at that time. 6 months down the line, the prices will also change. Right? Okay. So there are two ways of doing it. If you give it earlier, you have all your coordination, everything in, but you only need to share with 10%. You do it 6 months later, right? You save on that interest cost, but actually you get more problems later on. So that's something like management, a proactive management like yours, once it understands, will take the right call. We won't be talking like this to everybody.
All the industry, all the projects getting delayed. And everybody talk about.
No, but now see, like I said, the other buildings in Bombay, some of the jobs that we're doing, we're much ahead in the beginning. I'll give you a classic case of Goldman Sachs that was here. We came in when even before the construction had commenced. So we got the order in October 2015, right? But work on the building started only in November 2016. It's another story that will get over now by July. But 3 buildings will be over parallelly, all complete. So they gave enough time for design, planning, working. We had 4 different workshops in New York with the architects. So all that is now showing on the building. Sorry.
So, okay, that's what exactly you have given an opportunity today for all of us to explain our concerns and what is the problem to overcome this issue, right? At least in your future projects, you will take into consideration and fix the way, facade at the beginning. It helps all of us. Okay, this is what again. Because I have seen in Europe, one of the projects I have done in UK from Japan. Okay, you won't believe the panels are made, get ready, building is just started the foundation. The planning they do in such a way that everything should be, they should have it in there. I think of course India will also come. Gradually we are learning. I can see today in our industry a lot of changes in the facade industry. When I compare the 5 years back and today we are in technology. Okay, that's a top-notch construction industry. The classic example today in India. I think this is after years it was done in India. Am I right, sir?
Which one? Yes.
So I believe that we are going in the technology. I hope that future, let's start with L&W, the future project, give it in advance. So we work together, the market will gradually change that. So this is the last 2 points here. The latest control is the advantages of speed installation. Because it covers, suppose your panel is 4 meter by 1 meter, it's a 4 square meter. Maybe panels installation, manage the area to make out. So it has a great advantage other than the stick system and semi-unitized. Okay. So if you are bringing the finished product from the factory, complete quality and good control, environment, nice, detail, everything, the quality check product company installed. That's the image of the TCS Kalika invitation project. So that's the main screen now. Every time they say the main screen principle, how it's working earlier. Okay. Our intention to keep the water always from the first barrier of the gasket, keep always outside. There are gasket between, then we have second and third gasket. Okay, third, the final gasket is like a gas seal gasket. Okay, the second between the wet channel and dry channel, we always play the, it's a pressure decline system inside. Okay, is there any condensation in water in the dry channel, it comes out. And we always in the system, it's a flow-to-flow drainage. You have seen the earlier video showing that once the panels are assembled, okay, there is a splurge on screws, everything. Even your side also, when you're inside, you can inspect this one, the people are doing correct job. Okay, of course, our quality team will ensure that. Okay, so you can also be just look into that. I think these are the classroom facades. Okay, there is a normally the entrance area lobby. Okay, we have done. There's always some projects we've done. Even some people will use for Unitized and some people normally we go for clear glass because there's a lot of public access will be there. They won't see through the glass. So it can be done in spider in many ways. We can do it there. There's a spider glazing. It's a glass style. Okay, this all is a customized design. It's each and every building we have a unique design. The project design we are done in a Sapla with that they are 324 mm stainless steel which is span around 30-meter line. Okay, so completely it's a custom design based on the client's requirements. 30-meter company. And it's a nice facade curve and
It's a single post.
yeah, single post, tier 3. Tier 3 will build for.
Sir, can you explain the support system for this spider glass?
See what basically happened normally is truss. Okay. This truss always we have the angle on the window and window. It's same principle of the concept of the unitized system also. Unitized system always we have the panels is coming the dead floor on the top of the panel, we fixed on the floor, and the bottom way we have a structure which helps for the window. Okay. Same way here the truss is one end. We can fix it as a dead load carry. The other end will allow the expansion bracket, which allows the handle the movement, many things, structure parameters. Then on that, we are fixing the spiders on the, you can see on the tubes, all the spiders are fixed there. The spider arm, okay, which is holding the glass. So between the two glass also something they allow us more sitting long. On the edge of the glass, we have some constraints. Okay, the edge distance, the minimum should be minimum 100.
The spider is a structural member.
Sorry?
The spider will connect with some structural member.
Yes, of course it's connected. That is the purpose of this whole class. That is the purpose of the whole class. And that much harmony, right? So in some projects, it depends upon the height. Suppose if it's a 3-meter height, I don't want, I just go with a thicker glass, 20mm glass, without any frame, the glass will go. So it depends upon the requirements and we do the custom design based on your projects. So same tension rod cable system. I think we all should not discuss. I think we need a facade these days. Right? Why facade systems are bad? I believe you can read this one. So when the glass is used, the great advantage. Okay, when they're getting the natural light is penetrate through the glass from the outside to the inside. Okay, so and also the performance, keep the heat outside and inside. Depends upon the glass, you select the U value of the glass. Again, your client is rich enough to pay the good money in the glass. You can go the lesser U value will have a more performance. Okay, or then always the profile we talk about the thermal. thermal. Suppose if aluminum profiles are not exposed completely outside, you can keep the completely the heat inside is less.
What is the lifetime of facades? What is
Lifetime for facade.
what is the
As long as your building structure stays, the facade will stay.
few years?
Yeah, 50 years.
We design structures for 50 years, Jen. We give a warranty for 10 years, but nothing really is going to go wrong.
Of course, contractually we have to give a warranty. It depends upon the project's 10 years or doesn't. But I don't see any problem that the building. Though the building I started in my career, I've seen this thing there. See, that's the beauty of the thing which I have already explained. The control facade does not carry any dead load weight other than its own weight. Okay, that is the point here. And control is designed to receive the gas, water infiltration. I explained about the first grinding cascade, keep the water completely away, right? And the second cascade, third cascades, okay, for the dry channel and gas seal. These are the points. Okay, the glass most common glazing type glass can be used in the project. Okay, 6 mm is our thickness. The double glaze we had told you during the board. The Michelin glass is standard glass. Normally the people will use the standard Michelin glass is 6. So whatever gas space 6 mm. That is in a general. Okay, but depends upon your building, depends upon the size of the panel. You always recommend go for thicker glass because there are the criteria we have to satisfy the deflection criteria. The glass we have, okay, as per your project requirements, we have to see that one. Okay. So standard glass, we generally use a 6 mm glass. Okay, if you want a single glass, it's a bigger panel, then we always recommend also 8 mm. So these all things should be happening in the time of the commission because at the end of the day, the moment it comes to my design stage, if I say the glass, the client will not accept, oh, this is a variation, the glass fading, so many issues will arise. With that, okay, these suggestions also we can give maybe under the board and from the beginning of the project. And some projects, if they want a more performance in the standard glass, also they will go for double glass. Even sometimes the double glass normally this atmospheric air pressure will be there in the spacer between the two glass pan. If you want to have a better glass U value, you can always go for recommend the argon gas. Argon gas will give a better U value. Okay, that gives the energy, inside from the outside inside. As concerned, the lesser U value is a better performance in the glass. So this, if you go for more glass thicker and argon gas, if you go for laminated glass, then it performs excellent. But cost. General about the glass, and the glass may be used which is a transparent or translucent same as a opaque. Okay, always of course the vision glass is always a see-through. Okay. This one is the standard panel, is a single glaze. Behind the glass will have a shadow box and insulation. I think these design issues will already be covered in the earlier session. I think. That is again material selection for the material used in facade system, glass, aluminum. Following criteria will be considered for approval materials to be used. I think this topic I have covered in my previous session. Review of architectural feasibility allocated by the review on availability, audit, review of proposed system, various facade elements. Review of design in line with the needs requirements. There are some projects requirements. In the glass has to be selected with that particular vendor, he has to have a LEED certificate. Okay. So again, it depends upon the projects and requirements. I think I should wind up. This is short line approval system testing. The short line will be approval testing process and all this happening. And today you are one of your project, we are doing a test in Bangalore, so which is happening there now. I think the sequence of how the process are happening. That is a test way. So more or less your panel also look like it's like that. Okay. The test normally we follow the standards of ARMA 605. See, that is one of the reasons that for your questions I am asking now. If you do it on the factory, the manufacturing, what are the benefits of that one? Inspection of incoming materials and all, inline process inspection. This is going to see in meters. That is the way of this kind of relay that all the times taken from the floor and installed to the building. Working in fire safety installation.
So what do? You just replace the glass with the ACP sir?
Yeah, inside the glass is going to be ACP. That's
No special heavy requirement.
no.
Your Globe project had ACP as a standard panel. So just need to put it with insulation on it.
And when the vision panel especially, this panel is inside more than 3 meter vision area. Okay, so we will this area we will use anti-public with the center. Okay, and the other one. Depends upon the panel, depends upon the use. We do that. So what happens in the relay system now? Relay system is not possible. You cannot leave the panel somewhere in the open space. Okay, either you have to. We normally recommend to cover the panels with floor wise. Okay, we always go for installation in the floor wise. Okay, that is a continuous. You cannot leave one panel and we go for next panel because we can't slide it. Right? Say the interlock option will not work.
No, I meant later. Later, is it possible to remove one panel?
No. So the Unitized is concerned, that is one of the great disadvantages there. You cannot remove the panel after complete installation. If any glass breakage happens, so we have to build the side casing. Yeah. We have to build the side casing. So that is one of the great disadvantages.
But that's possible in the second unit.
So semi-Unitized is nothing but it's similar
Section
to
is the same.
see, you have to understand that you have to fix like it's the same as a stick system. You have to come with a modular and glass, you need to fix it. The glass will come with a perimeter frame. You have to bring it as a separate and keep it in the position and you have to screw it. It takes time and people should come from the outside. Okay, whereas the Unitized you see that it's a great advantage. Okay, you can always inside. But inside the building you are installing. Unless some other features are there. Any extra features, frames or something. Other than that, it is panel, you don't need to go outside of the building. You can just do everything from the inside. Have you seen the images or latest like 2-3 people at the top and bottom, they landed the panel to install. But whereas in a semi-Unitized, you can't do that. Any questions or minor?
Yeah. While designing the frame, there are two factors, maybe some requirements, the impression, the secondary self-weight of the system. In a building, the topmost will have a lesser load in terms of self-weight, the bottom will have more load because cascading effect of load. In the case, for higher floors, maybe more than 20 plus floors, it will not be a better option to de-skin too. That is, bottommost where load bearing is more, will be heavy clearance, the bottom top one will be lesser. Instead of going for only one step of the
No. See what happens here? Normally, any project at the time of before giving commercial, there is an internal report. They do the test. internal report. By doing that, they will identify that what are the places and where are the locations the winds are applied. They do some model and all these things, they will do it. Okay, so we get the internal report. But what we do at the time of design, we will take it 80% of the area. Okay, what is the wind is applicable. On that base, we will take it. Suppose if the project is some area, it is a 2 kPa, 1 kPa, 600, 800, the majority area we say 2 kPa. We will design the system for 2 kPa. Right. If you see some corners of the building, if it's a 3 kPa, on that particular area, same system we will use it, we'll put a reinforcement inside. Okay, it's mainly for the logistic reasons. Okay, for easy handling, customize, standardize the dies. Otherwise, you have to go for small quantity dies, which will be the cost to the project.
Then you will go and reinforcement.
Sorry, sir. Inside the mullion. So where we can do that here.
Interpret.
So wherever the iron windows are there, so we will tackle it by using the steel reinforcement. Okay, because it's a lesser area. For lesser area, I don't want to design the profile. If I'm going to design it, right? Okay, sir. Thank you very much.
Just picture and showing you the double stage facade. We said Hyderabad, which is glazing in the front, which has the calcium cladding. This is the ITC reason. Just few really stories state probably with the rest of the subject has been covered. This item of the special procedure starting survey and logistics delivery specialists. What is the procedure and stock installation? This is some graphic images to show the sequential manner. First, the survey is done. Panels delivered to the respective floors. Take inside the building. Rolling to the stack. Prepare it to start installation. Or the edge of the stack. If you will be the part of the floor. PKC project design. We have used cooler paint on the building on our lower textile and after the facade is done, we carry out the facade free water test as per the common standards.
And normally, what is the ratio for the water test?
What is the
Ratio, percentage.
the
Water test.
that is the facade area on which we do. It is normally on a selected location, 5%.
5%.
State plan, no generation each time. You can select these locations. I will select it.
It's very important for like site the access to the links provided. They will have started without any hindrance. So they find difficulties, like everybody that is not done, they cannot get the inside, have to take a long route to come. So all these affect the timelines. These will change. Use even take this code of contract using our shifting balance. Okay, we are asking question answers.
Yeah, thank you very much. Thank you, Mr. Raj and Coffee. Thanks for coming.
Yeah. Thank you. Pleasure.
Just share.
Any questions on your team online? If anyone's got anything to ask?
Anything else?
Okay. Thank you so much. Thank you. Pleasure. Thanks.
Okay, we'll wait for 30 minutes. Okay.
It was an educative session for you all. Thank you. Thanks.
have to pay some food for just for being behind. Yeah, what I will do, so you can connect it.
Come perfectly, but I will have coffee.
Hello everybody. We will start our next round of workshop. Let me introduce Mr. Mahesh over here. Mr. Mahesh comes from the Unitized Facade consultancy. He has got 27 years of experience in building engineering consultancy.
After that, actually, it's only 37.
Yes, he is working since 10 years. So he is specialized in aluminum facade, reinforced concrete facade, natural stone design, stone cladding. So he will support to us. And right now they are doing high multi-level car parking. So I'll hand over to Ganesh now. And he will take us through his expertise in the aluminum and general facade system.
Good morning to all. I think a brief about me. So I think the giants of India, they come with a big team and present it. And nothing to them. So we start from go back. Yes. See, the thought process, it should be always facade, anything comes in, it should be always in out of the box. You cannot simply do like that. You see, in India now, majority of the project is only rectangular building. No complex geometries. In overseas, they look at India and say they are all boxes, no other things. So I touch why we are like, where we are lacking, why we are failing in design and challenges. Who next slide? So you know the skylights within 50 to 20 years. What is in Singapore? It happened from 85 to today. Next, Hong Kong. What is a concrete jungle and today is completely based infrastructure, even in the concrete. You take Dubai building skyline. It's happened after 2004, and you can see the Kuala Lumpur skyline. 91. Okay. So, this is which city? You can see that after 2009. Look at 2014. What is Colombo? And look at, they have a vision, and look at they're planning for this. They are planning in 20 years also like Singapore or other developed cities. Just go on next slide. See this temple, anybody knows? Temple. This temple, its own tower is about 8 feet. It will not fall down on the ground. How many years old this temple? 1,000 years old. And recently, about 5 years ago, it's celebrated. Now it's about 1,020 years old. The yearly festival, the landscape still can accommodate 1 crore people. Go to the next slide. See, this is Chennai city skyline. I took an example, I don't know examples of L&W is doing a project all over India now. Look at this Chennai city 1990 skyline. Go next slide. And 2015 is a plus. Are we doing right thing for the future? See, architecture, design, engineering, and environment is the sense of identity, If we do not have a sense and identity, everywhere we build concrete jungle and we struggle ourselves. So this is why I should touch upon this to understand whatever you do, whatever you construct, whatever design and build. Always think for the future and the usability and friendly and as well as the aesthetic requirements and for the nation what you are doing. Or anywhere because there the technology, everything, keep on developing and they change the world. The next slide, yeah. See what is this? Skeleton, right? This is your structure of the building, right? What is next? Is your complete mechanism, your drainage, your cooling, your plumbing, Next, this is what you are doing. This is your creating your comfort. You are having the comfort of external temperature, body coefficient temperature, internal body coefficient temperature. So it is an air conditioning for 24 degrees centigrade, not to sweat. You want to work in a comfort environment, right? So you have thermal balance required in our body. So next, while designing, while Indians are wearing cotton, other shirts and things, pajamas and these dresses. We cannot wear like a coat everywhere, right? We think what we do, we open the street because we live in a tropical environment. We have to design a building for tropical environment to our nature. Next slide. We cannot design a building like what the other part of the world is doing because other part of the world they are heating inside the building against the cooling outside or the cold outside. Here we are having a to cool the building. So all the construction, think and analyze and execute the project, you can go to sleep. Otherwise, they will offer you. And whatever you pocketed your profit, So, because facade is vulnerable, so that's why I put this thing, enclosure envelope of any building Because the dress you only go buy cotton instead of buy a terrain or a silk to wear in the summer. They need your comfort, right? See, what is this? Ants nest, Go to next slide, please. Yeah, right. Then architecture created this kind of geometry globally. What is this? Architecture created accordingly. See, traditional Paris straw is available in the summer. Small birds go together and build the nest winter to against the thermal break to have a heat inside so they can have a comfort life. In the summer, it goes pick up the green and build these for better comfort. In the desert, birds has a roof, thermal transfer values, then good, next slide. The big auto industry started with no glass or anything. Glass because of the car invented in Europe, so in America, so they have to have snow falling and cold outside, so they need shelter when you drive, otherwise they can't drive. Change to shapes, then change to 2050 is a metal and glass and fiber. Future is only glass and fiber, no more metal. This is a revolution happening in the automobile industry. So when the technology changes, every 5 years, 10 years. You look at our codes, Indian code, IS 875, no change, NBC, no change for 10 years, 15 years, 20 years.
Now they are talking. NCC 2016 exam.
Yeah, because we evolve. So what I'm saying is, other part of our every 10 years the code changes because so accommodating spending money is not happening. Next. See, now we go to the design detail because I put these few slides to make weight of you. I think you feel the representative will be overloaded, so I want to reduce the overload from your memory. So, move on. Next. See, regulation changes in human error, as I said, and regulation changes in practice every year or every cycle. And building control design regulation changes in globally. In India, it never changes. IS 8147 done in 19 and still we maintain for last 30 years. So, then we go to design principles. See, what is a curtain wall? I think they presented by Anandi very fast. See, building facade which does not carry any depth load from the building other than its own weight. Simply, we can say it's a secondary element or non-load bearing element. We just attach to the building, it has its own weight, it reacts against a big pressure, positive and negative. That's all. You cannot walk on it or anything, only you put the impact line load for whenever cleaning or impact or anything you want to do it. Load transfer to main building through structure, through connections and closed columns, designed to resist air, water, infiltration, wind forces, seismic, and its own dead load forces. Just one of any available facade system is just to design with the above principles. See the key design factors for curtain wall. Structure is very important. This Chennai cyclone proven The structural failure, electrical. What is electrical? Why you have to design electrical facade? Lighting strike above 60-meter height. So you have to bond the facade as per CB guideline, every 200 square meter bonded to the lighting arrestor. Either lighting arrestor can be a lighting strip or all your reinforce from the foundation. You put a anchor, lighting anchor, then all your reinforce can be connected up to rooftop. Then your bracket can be welded wherever on the street, so the lighting can be arrested. Plumbing. All water heat on the facade and it says to drain out, right? All the facade for drain and vent path by means of pressure equalization or drain and vent path. There are few principles. So we see in the later stage, we move on. Then heating, cooling. You have to cool the cooling inside because it has to be addressed with the thermal breaks. Thermal break system, but outside is a 40 degree, then you have to cut the heat and you have to maintain the 24-degree ambient temperature inside. Then as it is, so wall properties. Next, in the wall property has to control heat flow in and out, control air flow, control water vapor flow, then control rate penetrations, and control light, solar, or other radiations. Very important. Otherwise, it will ask for sea change from the facade to inside, or you cannot see clear the even if you put a curtain, you cannot see clear the facade. The noise and fire is very important. See, fire is a very important factor thing because you not design the facade with the passive fire protections, where a vertical separation or horizontal separation comes. Smoke is faster than fire. 3 minutes all will die due to smoke. If you 45-50% burn in 1 hour fire, still you can survive. Then you will provide the strength and rigidity of the facade. You should not have rattling or other things, so you create a creep noise, so you cannot see them more. Then it should be durable. Okay, when it spacing when a building. Wind velocity is like through A and B, like a fake longer phase and two shorter phases. Towards the free wind on the ceiling height. When hit and it tends to be, it will be double the speed of the wind speed. So mostly the common conditions. Your pointer right? See, these corners all should be designed extra there, otherwise corner is more vulnerable than any other element in the facade. Please. Then what is this? What is red, what is green? This is a more working pattern of analysis of that kind of building. What you see earlier in a rectangular building, A and B phases. This is a A phase. General pattern of a wetting on a windward facing elevation. So we hit on the A. So the majority of the water wetting at the center. Because that, as I said, between the corners, the wind speed is 1.5 times or 1.25 times more than the. So most of this red portion is a less wetting space, and the center is the green is the more wet. And transcendent bullion intersections for this. So this is a glass perimeter which covered by a gasket, pressurized gasket, or by structural sealant and other sealant, or the gaps in the gasket length and the corners also make a leak, create leaks in the facade. So, no, okay. Next. See, there are two things. The only facade is designed with drainage principles and pressure equalization principles. The drainage and pressure equalization principle, water opening and forces, is all anyone eliminate the leakage. See, what is this? All diagrams. Anyone knows? Very good. See, due to gravity, water, due to kinetic energy can leak. Due to surface tension, water can leak into the facade. Due to capillary action, it can leak into the facade. Air currents also can push water into the building. Also can push water into the building. How to mitigate in the design? Kinetic energy, this is what you see. You need to have an upward right. So due to kinetic energy, it will not get leak. The gravity also will create a air vacuum. So and upward on both profiles. So the air pressure in the air there will not allow the water to penetrate. So we will push it out due to gravity. Kinetic energy also will create upward effect. So it will hit and return back against kinetic energy and surface tension. So another the same all mitigate the designs. You work together. Capillary action you cannot allow it. Capillary action always act on a direct through and through gravity and pressure. So capillary action should be has been cut on the pressure side. So you referred upwards. Then again air flow is here. You also covered wet, so air current happened within this small gap. It will flow, gravity pull down. There is a big pressure, also this similar air flow continue patterns. You can push it down to drain. So the drain design must address either one or two. These are the two options only. You can 100% seal a facade. The drain and vent path, they provide a hole for air intake and drain out. The pressure utilization, you have to design the chamber by volume of air intake and volume of water discharge. So you design such a way, so they way they provide this joint. So this joint must be sealed properly for any water penetration should be drained out. So you provide some kind of deep hole or some kind of incline slot, it should be drained out. So see this is a way, as I said, this is a drain and vent path is exposed in all the frames. So whatever the water penetrated, the air go inside and push it out. So this is a drain and vent path. So drainage all happen. 90% of windows, don't even put a slot, drainage and vent slot. That's why houses all houses leaking. Nobody has no idea. Right? Because most of the fabrication workers do not have knowledge and they not trained properly. So windows is very must. It has to be addressed. See, this is a pressure equalization principle. There is no slots, no holes. So what will happen? See, there is a two chambers, right chamber and left chamber. The mullions, and then this is on the mullion and is on the transom. This is perimeter connectivity yellow, and blue also perimeter connectivity. What will happen? The volume of air intake, the gravity will push the water out and it drain out at there. So it's a pressure equalization. No drain and vent path. Next. Then you have to design the first. These are all whatever we discussed for a train, water, air integration for a facade. Now we go into the structural performance. Is must withstand applied forces, as I said, ensure operations, faster safety. Safety is important, no? Even in Chennai, the cyclone, after rain stops, people walk, small incomes, suddenly something fall down. People stay to walk wherever damage building. Safety is an occupied inside is very important. So the visually also it should be safe when you do. You should not bend or curve or look. You should not give fear on the facade. So visual appearance also very important. So you want to limit the reflection. So you will make it straight and during night with positive and negative pressure. So it will look very clean facade. It looks very rigid. You have to visual appearance is important. Also, you have to do thoroughly check all computation and calculations for sizing, measuring, screws, loads, everything has to address. Also, very important in building moments. If you not apply the building moments, you don't know why glass is breaking, you don't know why sound coming, you can't repair it all in your life until the life span of the building. So, define the horizontal vertical formulation, give a greater flexibility in terms of cost savings, in terms of performance, execution. Otherwise, you not properly design a modulation, it's very difficult to get all these done. Then hardware is very important. If not choose the right hardware, window leak, pressure not engaged, they should be single point or 4-point lock or 6-point lock. Based on the size, you should be designed. Otherwise, it will fail. See, also structural performance, there is a two-way of doing it. 90% of the glass industry fail in structural performance because they do not understand the linear and non-linear analysis. They don't understand limit state method and working stress method. So you do working stress method and change limit state method, definitely close your eye and you can change 10 to 14% of cost savings. And it will be better system. You go to this linear and non-linear, when come to plasticity, you can eliminate all these distortions. Then in seismic or any timing, it will stay, nothing happened. I'm not self-providing ourselves. Chennai cyclone, we done 12 buildings, not even a single panel fall down, or not even a single damage. We have a letter from big clients like TCS, from SKCL, from Trill, from Tata Communication, we done nothing happened. See, why? The structural performance has to address with the tolerances, which we never do it during fabrication or installation. Nothing happened. You cast a concrete, over a period there will be a shortening of few mm or few centimeters. You're not addressing your design. When 4-4 deep reflection, you never taken care of it. After you remove the centering former, you put a temporary post for support until the curing period, you never address this. Then again, called settlement, you never address. That's why even sometimes people say leak from facade, not from facade, it should be from concrete also. It should be from brick wall also. You never know. Okay, next. Also tolerance, shortening, deep reflection, column. Next. Also, you very carefully you have to analyze the design, building plane drift, also building out of plane drift, and also thermal movement. And very important is this for everyone, all the contractors in the building. This is very important. Fabrication, installation tolerance is key. If you not accommodate this in your work, you will take a lot of site measurement, you end up doing wasting material, wasting money, to and fro, you lose at least 2% of the project cost. Testing. You not do enough testing, these are the failures. Not designed properly, not tested. So you see, this is what the common condition we discussed. Look at this building. All outer layer glasses are broken. One thing, load sharing principle has to be addressed. No, I can get the job done in 800 rupees. So it's like buying chapel for 800 rupees and cutting your leg, to accommodate a chapel, It's happening in India. So, product condition, all these, you see, the brackets are there. You spend money, all the brackets are there, everything there. As I said earlier, the wind funneling, is happening in this gap. Cut wind and east wind has to be addressed, and load sharing principle to be addressed, and product condition to be addressed. It will be very important in vulnerable material, any material. It can be glass or stone, or it can be a cladding, or it can be brickwork. Brickwork also can happen in space. It will happen. Together with the facade, brick fall down. So, the test, these are the very important parameters to test in a facade. Air infiltration, water penetration in static and dynamic, structural, load for design load and load flow, and seismic and behavior restraint. Really taking care of behavior restraint. So, whenever you clean the facade, glass get damaged, you tie back the facade damage. So, you have to give restraint load has to be addressed. Next. And the live load impact testing is very important. Whenever window like the Spider-Man hanging and cleaning, so during testing, coating testing, other testing parameters, transfers, dynamic testing, all seismic testing, all has to be done in the facade, so it will be quick and safe for use the building. Come to next. Aesthetic performance. After all these structural design performance, your aesthetic performance is very important. But you must achieve your operated line, especially because it's spending and investing on the building. It should be serviceable. You cannot just put the facade and it should not be non-serviceable. It deploy within 10 years. Retain appearance for 25 years minimum or 20 years of its lifetime. And selection detailing essential is very important. All detail you doing, selection of material is very important. And factory side inspection is very important. Coating, glass. Most of the time we are referring a detail one-to-one and see whether it's the right shop drawing or not, we will approve it. I think they have know us how we approve. So the process is a bit of painful process, but ensure building is safe. We have done more than 150 projects completed last 10 years. And now we, as a day, we have just simply come and happy and nobody call me for any problems. So, if you're not doing that, performance after respect on the facade. Go next. See, these are the issues. The bimetallic corrosions, all these leak failures, coating issue, water leak, wrong gasket, rubberized gaskets, not micro gaskets. So why you end up with all this after spending money? Then environmental performance. Even the heat load and glare study, how much lux level you are getting outside in the sunlight? Anyone knows? You get into 90,000 in the summer, 100 or 110,000 lux level you get it. How much you need? What's the lux level here? 300, these are 275. Whatever the lobby is about 600, 700. You need 1/10 of lux level should not penetrate in a building. Otherwise, you will get a glare problem, you will get a problem. Even if you look at outside and suddenly look inside the building, you can't really take at least few seconds, 30 seconds or 1 minute to come back to your normal vision. So lux level is very important in a building. In the glass itself, reflectivity is a key. So we'll go to next. Acoustic performance is very important in a facade. There is a nice criteria. In India, we are the only country required high level of acoustic performance because of honking in the car, no other part of the world. Because I travel with foreigners, they say, it is celebrating every hour, every minute. I say, why? In Europe, they have celebration. Here, every second you celebrate.
Every morning.
So, it's acoustic performance. And he said, you're not spending for this acoustic performance. So, acoustic performance is a noise criteria is very important. Even hotels, bed level require that. Occupancy rate is very low. And 400 crores spending another 40 lakhs or even 1 crore, they hold it and the investment gone to drain. See, must limit the noise, transmission noise, professor, between flagging noise. There's a few types. Okay. What is flagging noise, reverberating noise, resonating noise, all has to be addressed, and reverberating noise, sound deadening required, all this need to be addressed in an acoustics requirement. Go to the next. See, design parameter for acoustics is sound recording around the perimeter of the building, peak hour and non-peak hour. So morning you will start to record the noise level from 7 to 11:30, then you can relax for 1 hour, or 2 hours, then you again start the record from 12 to 3 p.m. Then again give a gap, then 5 o'clock when they start to record, the noise level up to 7:38. This recording is a key. Many people they never do the recording like honking noise like this. They will start with the 68 hertz, but nobody is doing that. Everybody starts to build hertz to 4,000. The contest of India, you have to start from 68 hertz to 6,000 hertz noise recording to achieve the 1/3 of the octave band. It's called sound transmission loss. From that values, you have to do a sound mapping on an entire building elevations, and you have to derive based on the sound mapping calculations. You have to derive a sound transmission coefficient. From the sound transmission coefficient, you have to derive the sound reduction vehicle index average. Then only you can achieve a exact required noise criteria dB level at whatever, wherever location you will find. buildability performance. Bracket should be designed with a three-way adjustment. Otherwise, you cannot do a buildable performance. You cannot install the results. Interface detail to be addressed to tolerance, structure, movements, everything, and accommodate. Also the insulation. Insulation has a two requirement when come to termination. One is for energy performance and environmental performance. Another is a fire. So both are two different material. In most of the jobs in India, they do this as a fire stop and do the same material as a insulation. It's wrong practice. It will not perform for fire stop if you use a rock wood, if you use a glass wood or a fiber wood. For fire stop should be a rock wood for 2 hours with a testing and should be a smoke stick. Glazing. See, there are various definitions for safety barriers, but what is the height required? Even some, see, normal average human height is about 1.6 or 1.7, right? 1.6. So you need to have a body to give you 1/3 of 1.6 height to be a riding height. IBC says globally as a 1.15 from the FFL. So there's a section, and the safety glass is only laminated safety glass which you can use for barrier. You can develop as a safety glass, but you cannot use for barrier. Safety barrier. Also, the ISA 75/1987 part 2 imposed code also says for the safety.
So what is this minimum height?
See, this is from the FFL as per IBC says 1067 means 1.1 meter height required. They like riding level. Because your body is here, you are 1.6, so you need your 2/3 should be go down. Otherwise, you go there, the body weight itself will pull you to fall down. Railing, I'm talking about railing. Yeah, transfer, if required. See, most of the IBC or BS says, 4062 says, you need to have a laminated glass internally or railing inside. But nobody practice that because most of the facade design as a railing as a spandrel band. So there is a horizontal something then the design has been
Lower height.
yeah, lower height, but it should be come to 9 m. See, safety also there. What is protection against impact? Manifestation of glazing. Anyone know what is manifestation of glazing? Manifestation of glazing. See, you clear glass, you walk through and hit yourself. You never know there is a glass. Anybody experience this? You just walk and hit yourself and get injure yourself. So this is the manifestation you need to do on a clear glass to prevent yourself injury. Safe window opening and closing, your limit state and all things to be designed. And you need to have impact, protection against impact, you will design for a point load or line load. And safe access to cleaning internally and externally. All body guard. 90% of Spider-Man, appearing guys in India, test shows that they break their ribs. What they go, their ribs break. Because they are not using proper harness. They not realize that breaking when they go sleep on the night. Next day morning wake up, only they know the hairline crack in their ribs. They cannot wake up. What is this building? Anyone knows? This is a Mazda building in Abu Dhabi. This is the world's first positive energy building in the world. Out of 169 project buildings participating in the contest, this is the zero energy, means the building never consumes energy, should not consume more than zero energy, but this building has a positive energy. It generates energy and supply to the entire Masdar village in Abu Dhabi after its own use. So one building, how much power required? So the facade is entire facade, skylight, everything generate power and used for its own purpose. Then balance, they utilize only 40%. 60% is supplied to the entire area of Masdar area for street lighting and other requirements. So Abu Dhabi government is paying this building whatever the power they consume. So the building there is no grid line connection from the government for power.
What's the built-up area of this? How many million square feet?
This is about 2.2 million square feet.
Yeah.
I think, I'm not sure, but you can Google it. You know, Masdar Abu Dhabi, world's first positive energy building. Come to human comfort on glass. What is it? This internal reflection, you know. So external reflection also plays a role. And radiated heat. You see, there is a lot of heat comes through the glass. Everybody feels that the heat. There are two types of major heat. There is radiated heat and direct heat. Then lux level, as we discussed. And visual light transmitters, day, lighting, and night. Otherwise, night you cannot go and see outside. You have to put your hand like this to see outside. Because the reflectivity factor, internal and external, there is a calculations. We need to address what is the percentage of external reflectivity and what is the percentage of internal reflectivity. Both has to address and work. And now fire. 6 million people seriously injured in fire per year average. And out of 60 lakhs, 10% will die. 60%, sorry, 5 lakhs people die every year on building fire across 170 countries in the world. So 85 to 85% death are mainly due to smoke, not because of fire burn. Come to smoke, smoke is faster than fire, as I talked earlier. Percent people get in the room of the fire origin. If fire origin in this place, if there is no proper active and passive fire protection, like 100 people, 27 people die here before you exit. So that is very important. Then active fire only suppresses the fire. It will not help you to evacuate. Helps help you to evacuate, but from the smoke, active is very difficult to compartmentalization. Only passive fire can do only compartmentalization and preventing the fire spreading. Active give signal you, warn you, give alarm, and it will suppress the fire is as much as possible. Passive will give compartmentalization and minimize the casualty and make you to evacuate and be safe out of the building. Next. See, there is a two-way fire spreading facade. One is a chimney effect, and another one is a leapfrog effect. So, the fire separation, the fire stop, all need to be addressed. for both conditions. Leaf roll rate, you need to have, as per the code BS 90605, you need to have a 905 mm height spandrel panel or brick wall, anything there if there is no sprinkler. If there is no sprinkler or there is no active fire system, then you need to provide this 905 mm height wall to prevent the leaf roll effect. If there is a sprinkler and active fire system in place, then you don't need this wall, vertical wall separation, but you need a passive fire protection of perimeter fire stop for 2 hours. So next, see this is what I said. The 900, if there is no sprinkler on top, the fire heat and it should not spread immediately on the immediate. So you need to have this 900 mm, 950 mm or 1 meter high. The fire will not reach to the next level. The intensity here is about 550 degrees centigrade, even reach 600 degrees centigrade, depends on the material you use. When you start the fire, what the temperature fire starts? 100 degrees centigrade, 110, 120 will fire ignite. And if the flame, the spreading index is very high, if the flammability is very high. They reach 500 to sometimes 1200 also. When the fire heat the slab and the slabs are designed for 3-4 hour fire stop and is pushed back the fire, then the temperature is up to 1000 degrees centigrade. So then when you go out of the air, it will 50% only will function like a 500 degrees centigrade. Then it's very easy to catch the next floor level. So you have to have separations here. If there is no active fire system in the building. So smoke protection also is the same. You see, look how if there is a fire take 90 minutes to hours to reach. Smoke protection is not there immediately to reach to the peak. So that's why most of the world 66 lakh people die every year in fire. 60 lakh people in India, 6 lakh people die because of this green curve. So this is a fire stop, vertical and horizontal. You have to provide for 2 hour fire rating, and it must be tested and performed. And also, if required, you will provide acoustic layer on top. Next.
One question I have. So if this is provided, then it's fine. I mean, you don't have that spandrel, because many buildings that we are working on, architects design it in such a manner that they want to see floor to ceiling glass. So what happens after the spandrel level? That spandrel is just the slab level. It's about say 300 mm, and then they want a huge sheet of glass which is 3.7, another 300 mm. It's a 4 meter floor to floor.
Without spandrel floor to floor glass, you're talking about.
Without spandrel.
What's 2-3 slides and yeah. Go back. Yeah. See, okay. If there is a active sprinkler fire system there, then you can go 4-4 glass.
Right.
Proper passive fire protection, active fire protection, smoke detector, and you have the alarm sensor, all are in place.
Everything up there.
You have 100% active fire system. Go to the next slide. If there is any one of the system of active fire is missing, panel or this vertical wall should be 900 meters high to avoid the leak from the right out fire catching, fire spreading.
This new MPC mandates that you have to have a sprinkler 600 mm from the facade for all the glass facades. Mandatory.
Yes, mandatory for all the builders. Mandatory.
Glass facade has to have a sprinkler system.
See, Not necessarily, no, see, because we are failing the implementing this, it's so stringent. I gone through the English, I am a part of. So they say they experience, they conduct so much firefighting and we require this, all this is fine. There are other ways and means you can optimize it and get it done what globally doing, like Singapore, Hong Kong, in UK, US. There's a lot of ways. This is the most stringent code is NMPA. Everything is a British standard, not even European norms 1/091 or whatever. So protection and all the put in place, otherwise you need to have this no, see, this is a raw code for design with the continuous trade. On top of is intermittent CP672 or CP600 or this report from Dow Company you pay. This will cover 2 hours back. It will for more than 2 hours. The top of this is for acoustics and also is a spreading trade. It cannot go damage the luminescence, otherwise structure the 2 hours performance will go. It can use for tolerance and other things.
So this gap should be over current resistance.
Yes. As per NFPA 2595 and we should just BS 476 part 1, 2, 6, 7 and 22. Security, acoustics and glass facade design code, these are the parameters. I think forced entry. What is forced entry in a multi-point blocking? What is bullet resistance? Resistance is a 6 mm caliber to maximum 55 mm caliber only can do facade. After that, what is called? What is the bullet range? Raise the velocity and the projectiles. So 6 mm to 55 mm only bullet gun can carry, man can carry and shoot. After that, it will fire, it will hit back in. So it's called a grenade launcher. So the building facade has been tested up to bullet resistance. We did few overseas and lot of design and we did few projects. So blast resistance also is another level, another security facades. It can be designed for 20 to 200 kg. So these are two very special acoustics we discussed. It's called reduction weighted index. Is 45 degrees average, but is the match criteria very from the user requirement like hotel or hospital or any other user requirements. Now, how you build and maintain a facade? These are the dancing covers of the way we designed, but project didn't taken place. You can see the elements on rooftop, how this is in a big tower, things. So, open. Also, the integrated signage and lighting and building integrated photovoltaics, as we discussed, generate power. Infill materials. What are the infill materials used in facade? Glass, solid composite, metal panels, natural stones, and GFRC, GRP, is I know the right, I think brief on the glass already, right? They can be very strength and handy. You're going to, then I don't push too much on glass design and parameters and performance. Go to next. See, metal panels, these are metal panels and glass, is a combination solid or composite stainless steel, titanium sheets, vitreous enamel sheets, and copper or real zinc, materials can be used. Stone panels, you see, is a complete stone was done by us, is good by me. So the box building, so we put there. Is to do stone cladding into the facade parameters. Even can use the unitized panel to install few projects. And then you so there are few types of stone installation in a building. Pin, curve, embedded curve, then keel angles. These are four ways only you can do a stone finished facade. Next. Okay, this is I think they will speak on much of this, right? I quickly run. There are only major four systems used in the system. Some of the critical constructions we have to use the ribbon type system. So stick system, you put mix the mullions, then transoms and mullions. So it will be then infill the glass, then you fix the spangle panel with manual. So this is the sequence of stick systems. They use like this. Semi-dies, you put the mullions. Next. So Unitized, you can see completely factory assembled, and I think they will you. So this is the Unitized curtain wall system. Ribbon curtain wall, we are not much doing, but globally we are doing it because of lot of reasons. Construction sequence, core finishes, ceiling finishes, they want to go first, then want to finish the facade. So these are the ribbon type, you can attach as a system like this. And there is a glazing, this is a system, red glazing, such as ribbon for ceiling glaze and other things. Bond glazing is a spider glazing. And glazing type not directly related to the curtain wall systems or by means of clips and with the standing seams, adapters, and other things. So dry glazing, just pressure plate and glass, the two gaskets, inner gasket, outer gaskets, you pressurize with the mechanical screws. Is dry glazing. Next. Wet glazing, there is a double sided such as ceiling and weather sealant without any mechanical greasing, purely on a weather sealant. Bond greasing is your spiders and other molding through drilling a hole on glass or by pipe fittings. See, then glazing is a two type. In Europe is mandatory, however, two side capping is required by mandatory. Why in Europe mandatory? No, wind was lesser. Not even 50% our wind force. Europe never go more than 2 kPa. So we need to do side capping on Europe. So sometimes acid will also do side four side capping. Go next. This is basically four side capping. All four sides there is a capping. The front they put a big cover. The right side they put a small cover. You can see capping vertical and horizontal. Go next. Two side cap, no capping, completely structure glazing. Glass to glass joint. You can see patch fitting or spider. Next. You can never done this, but we do this. This is a complex facade, I think we're running out of time or huh? This is a 3D geometries, and this is a standard rectangle building we mostly do in India, Come to next. There is a limited or no repetition in facade design. You can see all shapes. And again, you compare the limited, technical, and standard panels. Then again, trapezoidal geometries, no rectangular geometries. Then warp geometries, all these dancing towers, warp geometries. Then there is no wall for 28 meters length. It is this puzzle. And one side is a core wall, another wall is a steel structure. You can see any mullion or anything, any column, we can do it for 30 meters. See, this is what India needed, not doing practically. Everything will be written. And this is a good example. Here is a little more wall, and that time there is no wall. You go to terminal 2, come out of the metro, you can see there are big glass boxes. The world largest glass box in the world. You can see this. We did it in a membrane structure with a cable, no tensioning, and with the fabric. This is a Bangalore airport. Oh, this is the largest horizontal cable car in the world. 400 meter by 100 meters, single cable car. Entrance cannot be in arrival and departure down. Next, what are the issues faced by facade designers? See, this architect creates such a shape and increase the cost. And there is a need for differentiation like with the traditional forms. Like what I say, rectangle or square. You need your shapes and things like that they create. You can see accommodate construction segment, how you do it. There's a 80 mm shifting sway, and this started from every floor. You can see how it's bent and gone inside. Then convince local authorities and reverse intent. You see all irregular boundaries, and you can see this. This is a reverse team. This is in another part of Mangalore project in Sentosa, and this is the material. Is availability and designs on shapes. So interface with interior decoration, how we get all these irregular transitions should be integrated. So you need to coordinate. Maintainability, access and maintenance. Then now I take a small examples of this kind of work geometries. How we do. We run, I think, the surface for this kind of locations, how we get it done. Otherwise, water leak, everything will come. This kind of shape, go merge the facade, go integrate here. It's a very complex nature of integrating all things. First curve facade came, and this is a beam twisted facade in the world. This is highly twisted facade in the world. Next. The surface is single or flat plane. Second, it can be single or double curve, or it can be four-sided panel lying across the surface into steps, or the surface is not developed from a flat plane. It should be modular plane, and a rectangular plane not lying on the flat surface of the plane.
We did that, like
yes, boss.
The top is a skylight. You can't see it very good.
It's not a skylight, but the slab actually is a put a glass. Actually, it should be a solar panel.
But it's glass there.
Now it's a glass because of solar panel not input there. Because it's a slab only. See, this is a traditional rectangular facade. All Indian are practicing this. Then modular design and just take away go and fabricate install. Come to complex go back. Come to complex geometries. Step 2, 3 is very important. Otherwise, you cannot. Angle of tilt, angle of inclination, angle of arc, everything analyzed, and we plot in a Excel sheet. Then we color wall, inclination, perimeter, everything. Then select the panel modulation. You need this kind of panel modulation for complex geometries. Then you need to formulate this kind of designs in parametric. Use 3D softwares. How many people use parametric here? Anybody? Huh? Anybody use parametric design? Must have been only inverter and SolidWorks. It's not parametric. You need right now. You need grasshopper. You need to interface with this Tran 7. Very fast. Okay, I think you all are very. These are calculations to design a complex facades to achieve a 3D designs. Go to next. Draw each panel individually, then only you can achieve. And need to consider individual connection detail like this. Your connection detail cannot be a standard application for any complex geometries. So, issues faced by the designers, different and break traditional forms, cost increases, construction sequence, reverse trend, price and skills, and material availability. Next. We go for few studies. This is a complex of. See, there are 5 types, 6 types of systems you can do in complex geometries. What is the step? Next. See, this is the mistake division of the panel. 1, 2, all projected out to achieve the facade. Otherwise, you still need money to build the glass to build it. Without building, we take it with the next. Go back one. Yeah. See, these are the twisted facade the world is not done by us, but done by us. Okay, next. See how we geometry. Double curve, twisted. So you can color it first and understand the double curve and twisted. Second. Areas of below floor and above floor. You will mark and superimpose, and you need your string point fix beneath floor, below and floor above, and set points or curves and get the differential dimensions. You're not able to get differential dimensions, it's not easy. Next, then you need your few formulas. You will create your math card. Anyone know math card? These formulas for radial and milling grids and transom grids, and you plot it. And see, these are the radial mullions. You rupees. Professor, how much you got? You need the money, right? So 35,000. So we can do 25,000 to return your first we can cover. So you cannot make money. We should not allow you to make money, right? Yeah. Not very but see, these are the studies you have to do. Put everything in Excel sheet, Excel macro is very good for you. That also can integrate your stack pro or stack 7. You get this maximum work corners So all rectangle is 67% use a standard panels. Then we use small odd size panels, even is rectangular, but we can achieve the job. Next, see how we don't use one die. We use only one die. Exposures. So do the contractor just like this after they will put bent glasses like this possibly wrong. So the greases 51 inside with a vertical mullion and still you can achieve the curvature. So next, this is another step facade. You know this able how this building form. These all glasses are same modulation. This floor from this portion to the other portion of the curve is the same. How they achieve? If we take this example of this project, go next. Is a summer tower, is a 50 floor, right? Next. See, the ground floor and 40th floor is the same floors. In between 20th floor is a rectangular floor. So we studied option 1, option 2, option 3. See, option 1, stick system, slow installation, not recommended for 40 story. Option 2, fully unitized, possible, but we don't recommend. The unitized is recommended because you can achieve the unitized is both color panel or trapezoidal panel. The cost would high, but expensive. So when we choose option 2, semi-unitized with assembly mullion, like unitized, you can achieve that. Next, see how we done it. You look at the corners. These corners. So we try to turn the corners instead of point corners. So you can get the geometry of the building. Otherwise, all these bent twisted to meet the point is not touchable. Next. So what we need in the architectural design, they provide a horizontal capping. We use a horizontal capping. Achieving geometry twist. Next. System slightly because it is slow installation because we mix semi-unitized and assembly mullion, but static percent savings and still works very well last 7 years. Next. This ocean heights. Next. This will be done in Dubai, ocean heights. Next. See, every floor, all floor plans are the same. 5 floor up to 80 floor. The floor layout is the same layout. But every floor twisted 500 mm, every floor. Same floor plan. No change. Typical floor plan from 5th floor to 84. But only shift 500 mm. We did the study for service, overall stepping, how much coming. So stepping is not exceeded more than 64 mm. And what is it? Never exceed 15 mm or 16 mm. How much glass allowable for reflection?
20 mm.
So go back one slide. So it's less than that. So we don't need the bent glass. Okay. Then we choose options. Whole panel wrap, or only the spantle panel only bent, or display every step by step installation. So we analyze the plan. How to this is a small twist to get. Next. So what we did on the panel modulation analysis in non-linear. So 20 mm is a deflect, it gives 15 mm to pull in. So we put adjustable nut and bolt, facade, we tight and pull the facade 15 mm. So we did a non-linear stress analysis. So flat glass, we force to bend after fabrication. Pulling back.
What did it look distorted?
No, because of 20 mm, and the see, you need to have a twist. The facade panel has to be fabricated like this. You need to have a either spangle cut and only the spangle bend like this. Full swell, go to the bracket, hook on. After install, we adjust it. So slowly pull the panel and install. Yeah, that's what I'm saying. The stress analysis you have to do. That's what I go back to slides and do it.
Which will be uniform.
Yeah, go back. See, that's what I said there. You said tension, right? So we said 16 mm, right? How much? They say the glass can reflect up to 20 mm. So we already 5 mm here, safer side. So 20 mm we pull. Okay? We're not to pull 20 mm. After 20 mm, the glass will break. Up to 16 mm. So this overall stepping in its 64 mm, So you 1.2 meter, you take a triangle, you pull 20 mm, you get 600 mm pistol, right? Next, these are one of the projects we did in Delhi. The next, see, is a reverse study for triangle modulation. You cannot do a standard study. So we put this in elevation, diagonal, then we volt the floor, upside down the building, the studies. Then we modulated this panel, then we modulated, put all these panels, the whole study all we can modulated. Then next, flow, right? You cannot put a triangle panel. You put a triangle panel and every panel needs to be fixed. So we did a trapezoidal panel. Here. So we take two triangles like this on a panel. These two triangles can bend to achieve the curve. You create a panel, you can bend and you can install. Curve. Next. So we can install all straight panels, no curve. Go next. See, these are the work which you can achieve in all the places. Not the bent glass or bent extrusion. Fixing details are the key. You can achieve multiple shapes. But the fixing detail is key. Next. So these are the we discuss. Next. See, these are the assembly points. How you assembled, corner cut. So you need a 3-axis or 5-axis machine, perfect angle. So you can achieve down to down. Next. See, this is what shift. You either you shift, or you fish scale it, or you complex scale, or you do it, or just cold bending or what. We do all flat panels 99% what or cold bend because problem, fabrication problem, transportation damage will not happen. Will not achieve good finish. Different approach next. These are the non-linear analysis. It is analysis in only step. These are the complexes of how you design. Next. You can go to this thermal samples. Next. Evolution. Next. It's the density covers, the shapes, given the bricks. The facade, so it will work. So a lot of hand sketches required. This is a EKP. We did in festival ground in reservoir Sentosa. All light-based structures, how optimized, how this all can be achieved and done next. And this also double sleeve flexible system. It can move here and it can move and lock. Next. And see, this is the evolution of the facade. How you achieve this 3D curve? How you achieve perforated 3D curve? This is unexpected origin. There is no origin for it. What do you mean by no origin? It cannot be a rectangular, it cannot be a square, it cannot be a triangle, it cannot be a circular, it cannot be a oval shape. So there is no origin for it. See, this is what we get in integrations, how the geometry can be done. Next. See, these are the one click. 1960s, 70s onwards, globally buildings are rectangular, high rises, and all these. Today, next buildings are creating this thing. Next. Parametric modeling. I was involved in my group. Anything challenging, they will call me. I say I'm not. I always say busy. I'm not interested. Because he immediately goes to ideas. They don't think process, no thought process. Whatever I say, first 1 month, like they will struggle. Then I step in. So you have to do what you have kerchief. Just pull it. That's what. For example, it's a kerchief. And it's called longitudinal base because of hypotenuse. And it's a transverse base because of the equator triangle. Right? Come to here. You need to know what is the tricks of complex geometries. And come to here, we draw this line. You just cut here and pull is gone up, right? So the balance portion lying on the then your boundary line. On this, you draw a boundary line of this shape. So the boundary line is this building is going to come up. Surface generator of you just put a kerchief, draw two lines, draw this complex geometry like pouring oil on the surface. So it's absorbed like one, no origin. You cut on any axis line, then lift up, you get next. So this is called parametric, it's called post grid. You create a large size panel, like for connecting between one column. Let's create that one. 4 meter by 2 meter become 600 by 800 by 800 or modulated and become this one backward. So this can be done in this called crossover modulator. It can be integrated with the CAD. Any software will be integrated. Even you have an app, mobile phone can integrate. You take photo of me and you can integrate through this and you can create my imaging. Okay. So the cut surfaces, what we drawn, right? Like water oil absorption, right? On the surface. Next. This cut and remove this, cut and remove the other sides. These are the skylights, roof final shape. This is the building. Next. So below we are directing a wall, facade glazing. Then if this is the building shape, architecture. Next, how you do it? Because no origin, you have to do form. So you've done like a free form. You can do in one panel? No. You have to create this undulating freedom facade with the dots. How panels can be created? You have to create a grid with the dot or line. Then only you can form a panel modulation. So we did a grid dot. By dot, you can make triangulated panels, trapezoidal panels, by three panels. Next. So we are taking a trapezoidal panels or triangle panels. This only can be do. Either you A plus B or C plus D you can do. Next. So what we end up after this in this modulation. So too many panels are created. So this less lines. So how we do it? If you do this, a lot of work on the gap and a lot of cutout. You need this 150 mm, 60 mm, 30 mm this gap and required for forming the down. Yes. So we choose this option. So how we get it? As I shown earlier, you cannot take too much mistake because these gaps all will create troubles. So we choose pole bending and warping. Pole bending, as I said, your detail is key. Fixing detail. So same bracket, same metal mullion, 60 mm gap, 20 mm gap, flat. So same design. So in same panel can achieve without bending, without different panels, you can achieve the facade. Next. So in the parametric modeling, you will use influence your AutoCAD, your SCAD, your STRAND, your 2D, your 3D, your Rhino, everything can be integrated interface. Then you get this geometry, freeform facade. Next. So go by one, it will generate, you can see the line CG. So this is a geometry given by the architect for this, and this is a modulation for the building done in parametric. Next. So step one is this. Now we put this design into dots, then we need to fill up the glass for this geometry. When you do this program, all these different colors created a geometry and modulation here in the interfaces with the Rhino or you can take the Revit. very big over 3 files, but very difficult to take time. You enter one command, you wait, and you copy and wait. Okay? So right now, you will pull and you number it all the modulations. Next, all numbers are done. Next, see, again I said, same unitized system, same slab, adjustable rods, adjustable bracket, hook on facade, everything is on hook on facade. You need to have adjusted strut design to adjust the facade in and out. You can push it, the facade will like a bulge like a balloon. You circuit the balloon, it like a flat. Like that, you have to design a fixing system, flexible fixing system to address. See, now the glass has been formed and this kind of shapes, numbering, all installing. So this kind of numbering pattern, every glass can. You see, look at the height of the man. 2.1 meters, the glass will install 6 meters. Installing by 2 man, 3 man, not 20 man like in India. Go next. Look at here. 1 man and Kutola, 1 man below, another man sitting. So all hook on, the strut will be adjusted.
That's because here the fronts are given to you. And that's because you can bring your crane, you can bring your cradle, you can bring your infrastructure close to it.
Yes.
When we work here, what happens? Everything's working together.
So as Spider-Man, you know that you can do it.
Yeah. Easier way.
So finally the building achieved. So go back. See, we did this is one of the complex jumping in Chennai. It could be one of the best complex building in India. Except for NDCA, when tests go there, nobody wants to stand here, I sit in the chamber. So they said, because I am signed, And first test is passed, 9 kg. And you know what is this? You know what is this building? TCS Canvas. Butterfly. This tip to this stem. See, 70 meter from this tip, then again we cannot be. See, we will form the grids, Boolean modulation, all this we done it. Next, we give the radius study, 4 below, 4 above. Next, again we done the similar formulas. Next, modulations. Next, it's a program. 5 geometry, 1, 2, 3, 4, 5 geometries with this analysis. Ulta, reverse, and you color it. It's very easy. We done this in AutoCAD, not parametric. Simple 2D AutoCAD, LD. Go back. You do in 2D and integrate the lines, automatically given 3D. How you flexible with your AutoCAD? See, we've taken 1 geometry, 2 geometry, 3 geometry, 4 geometry, and all integrated later. We know where is the radius piece, different location. So node points anchored, integrated, we use the back nice. Then see for this slab, 90 reflection. 70 meter cantilever. So we given people say spring, come with a car stock of spring, ever spring cost 1 lakh, everything they said. I said no, I need a good metal fabricator. I said only I need a metal fabricator. We need one wishbone here and one wishbone here. So any deflection you can arrest simply on a wishbone bracket. Otherwise, you need a bracket like a jack with a hydraulic suspension. Every bracket costs you 1 lakh. We simply done it. 70 mm, 90 mm the total reflection is 100 mm per mm in the entire tower. Absolutely, we reduce to 40 mm, 30 mm, and we arrested. Here, and this is side joint, this is side joint. We increase the side joint 25 mm, 25 mm, 50 mm reflection arrested. The glass will not break. You put 1 point fixing, glass will break. You put one wishbone, two wishbone, you take both directional movement, building stay and light reflection can arrest. So this is again slightly the complex of this project. We did same study on the top, we can bulge on thing. So we put a wishbone and the T, the huge EPDM name station. Who is going to see on the top of the pyramid? I want to put in one even aircraft or helicopter to see, right? So we put a nice detailing with installation with EPDM. It moves left and right and move this way because we provide a slot and we done it. Because the building, it moves like some FEMA, And this cyclone, nothing had happened. Next. Okay, this photo building not to get okay, good. I think time is 3, right? No, this only it's looking like a car, but facade is to maintain like a car, quickly run for 10 minutes. So how you often maintain your car bikes? Every 15,000, 10,000 kilometers, right? It takes 3 months, right? Like there is a cleaning cycle required for a facade every 3 months or 4 months. So accessing and maintaining a facade is a key. Then only can replace a facade. Next. See, this kind of jumps and replace the glass is not easy. Next. So you need to have a zip extended up to 25 meter, or you need to have a suspended for glass replacement, or you need a guided control. Then all these should be integrated with the facade design. If not integrated, you cannot do anything. See this next. We also do a color mapping on which equipment can play which facade, which area is very key. Next. See these are machines on the rooftop, 1, 2, 3. All 3 machines located for 3 years because 300 meters. This machine can come to 20 meters. They cover this can cover this portion, that can cover that portion, that can cover that portion. Next. Then you need power and water for maintaining the facade at the roof level. Next. And it's a foldable facade, how we go inside and clean. So you need to provide a gap. We did GCC right from there.
Yeah.
So we provide every floor catwalk, double skin facade. So next. And you need like a cost screen, to clean the facade. Now this sloped facade, it acts like from like a wiper, Next. These are the full expensive up to 22 meter. Is a parking condition, refractor, is a machine. Next. See that this kind of building, how you clean from here. See how you start. You cannot directly land here. The wind throw him out. So what you need a soft rope system. You have to drop from here, clean, come, and you can come here. It's real cleaning, soft rope system. So this is a guided control required. You need to customize all these details. You need to pull and pull out. Because the arm can go only 800 mm, right? After that 1.20, I cannot touch everything, right? So I need to touch, I need a arm to go close to it. So these are the designs required to do it. Like this, in between 2 towers, the knee, how you go in, how you expand, clean, how you close, these are very critical. In the integration is very important, opening, This kind of things, all these articulated curves, you need a luffing required. Luffing design is prepared in the system. Otherwise, we cannot maintain on this kind of complex geometries. See, if not that, these are the failures. No, total work point, people die on this. Next. Design, bone jam cannot recover in a helicopter or something recover. Next, see suspended, they don't know how to go back. So, and next, then very importantly, bimetallic corrosion. 5 years, after 5 years, the guy go, the rusting will make it to fall down. So, whatever system you design for safety, life safety, is very key when it comes to building maintenance and other things. Next, so testing maintenance, go back. Next, this approval of shop drawing, we check thoroughly on all the equipments. Next, then we test in the factories itself. Push it out, pull it out, put a weight, counterweight, check everything in the factory before ship to site. Next, see there are two types of coils. What is the difference between this? What is the difference? Called traction coils, drum coils. You should know which one use where. You accidentally put the other one here and another one there, you hang it there, you cannot take it back. So the coils design, all this is designed, even for lifting material like a winch also is required. Next. So you see that's why the induction motor, brake motor, all these letters, see we tested a counterweight, all these. We test together with the man safety. Next. Again we loaded a counterweight. How the glass replacement goes, the glass weight tested on the monorail. Whether the monorail can take the glass load or not. So again, is a car maintenance like a certain maintenance. So any project you do until your defect liability period or warranty period, you should ensure the person will be clean. Next. That's all. Any questions? Thanks, boss. Okay. Thank you.
If you stay after the lunch,
We are going to go to the airport by 7 o'clock. Why?
because we have some question.
Whenever I leave to the protection is coming, how to clean the person below the
Protection coming.
protection. Because the landscaping is developed next to the facade.
How much is protection? That's a question.
2 meters, 2.7 meters, 2.7 meters.
2.7 meters.
It's on second floor to that. So below the landscaping is coming next to the facade.
At ground level, you have aluminum.
Ground level. See, the building is 10 floor high. And the second floor, the ACT projection is coming, which is say 2 meter to 2.7 meters.
See, you see the cradle, but then you order a cradle 3 meter.
Swivel here.
Yeah. So then you swelling the cradle, and people can walk inside, go reach 1.5 meter, 2 meters, and 1 meter and can reach. That's one option. See, the cradle will be suspended like this, like a bucket. So the frame will be there. You rotate. When you reach the below, come down. When you come down, this is a canopy. You come down, go there, you rotate, it go underneath.
But when you rotate, then you have only this much of area available to you.
Yeah, of course. That only you can go up to 1.2 meters clean. What is the weight?
So we said the extension boom you need.
Okay.
See, what happens is that if I want to reach, let's say, to him, and I'm standing in my cradle, I
draw something
stroke
to
him.
you.
If I want to reach to him, you need an extension boom. Okay. It's like how you clean a, let's say, you want to clean the roof, right? So you have that long thing.
Telescopic.
Yeah,
Yes, sir.
you can clean.
See, this is your building, you say 2.5 meter, 2.5 meter, 2.5 meter, 2.5 meter.
Yes.
Right?
Yes.
So you drop down the cradle. The cradle is here, 3 meter, suspended to the frame, and inside is a rotator. The floor there is a rotator table. Okay? So when you rotate, it will go here like this. Underneath, and you can clean. So from the center, 3 meter you can reach 1.5 meter. So another 1 meter, 800 mm hand can reach. That's one option. Second option, you see there is a articulated, if gravity comes, the counterweight, then it has a two counterweight. Okay? It comes here, then the gravity will go move here. The counterweight down will be suspended here. So you can reach, and building from this 2.5 meter. It's expensive. Swelling grading is the best cheap option. 2 meter.
So
It's continuous projection or then you can use this. Otherwise, you create between 2 floors. You will create provide one access openable. Then on the top of the canopy, you can put one right, the key and break the key. You can go in clean and come down.
So on the ceiling, monorail. So the VMU should be purchased according to the requirements.
So pay me a fee. Pay me a fee. Send invoice. Send invoice. Okay, questions? No.
Any questions? You can still lunch if you get.
Foldable facade. See, that is purely actuators. Chain actuators are very, you need a guided side frames. You need to push it and pull it. So it will open. You need intermediate inches. What are the shapes?
So along with the type of facades you explained, the twisted form of that. Kinetic facade is also a new element which utilize the design dictates of the temperature and the climate. So the box comes in out, the box goes in.
We are doing one in Saudi recently in
Executed as a net part is
Nepicon. That is a oscillation sheets. That's a lambda by sense, right? That's that's a passive negative facade. Permanently fixed. You need the active negative facades, you need to have actuators. But for your money, you have money to do the project. Huh?
there is money.
Then you L&W can do a sample project for India to everybody.
Yes, sir.
Yeah.
Okay, we'll have lunch. We'll meet around 2:40.
Thank you, everyone.
Yes, thanks, guys.
Thank
One day, only by Mahesh.
Thank you. Thank you.
Thank you.
We'll have.
Yeah, we'll have lunch.
Come.
Thank you.
Okay. This is just like
Yeah, yeah. See, the last time, yeah, yeah. Okay, I will look into it. Actually, we announced last time I'm there in the last week, before that I am there. We are focusing on verification of and the related solutions. What has to be done? Verification concern. So, this one represents the same. That's why the people have to get that. This is what I understand is every customer for each defects and everything, it's supposed to be good. So I will have a word with this.
सब कॉलोनी में तो बड़ा है ये, सब सूख गया, कोई नहीं छोड़ा, सब अब लेके फेंक रहे हैं, लेके फेंक रहा है,
अरे ଟିକେ ବଡ ଜାଗା 5 ଷ୍ଟାର ତ ଲାଗିଲେ ଟିକେ ଦେଖେଇବ ନା ଭିଡିଓ ଫାଷ୍ଟ ଟାଇମ ସ୍ଟାର୍ଟ
ओन प्रोजेक्टर
निजे प्रोजेक्टर कैमरा लगे क्या लाइट
இல்ல சார் இது பெட்டர் காப்பி பெட்டர் காப்பி சிஸ்டம் Yeah, always in
Every hour I spend in this, I learn so much.
ಚೇಂಜ್ ಮಾಡ್ತೀನಿ ನೋಡಿ ಮೇಲೆ ಇಲ್ಲ ಪ್ರೊಜೆಕ್ಟ್ ನೋಡಿ ಕರೆಕ್ಟ್ ಬರ್ತಾ ಇದೀಗ ಈಗ ಬರ್ತಾ ಇದ್ದ ಇದು ಅಲ್ಲಂಗೆ ಕಾಣಿಸ್ತದೆ ನೋಡಿ ಇದು ಈಗ ಸ್ವಲ್ಪ ಮೇಲೆ ಇತ್ತು ಅಲ್ಲ ಇಲ್ಲೂ ಅಷ್ಟು ಹಂಗೆ ಕಾಣಿಸ್ತಾರೆ ಇದನ್ನು ಈಗ ಕರೆಕ್ಟಾಗಿ ಮಾಡ್ಬೋದು ನೋಡಿದ್ರೆ ಸೆಂಟರ್ ಇದೆಯಲ್ಲ ಈಗ ಅದು ಹಂಗೆ ಇದೇನೆ ಅಲ್ಲ ಹಂಗೆ ಕಾಣ್ತಾ ಇದೆ ಈಗ ಕ್ಯಾಮ್ರಾ ಅದ ಕ್ಯಾಮ್ರಾ ಅದಲ್ಲ ಅದು ಕ್ಲಾಸ್ ಬರ್ತದೆ ಇದು ಫ್ಲೈಟ್ ಇದಲ್ಲ ಕ್ರಮ ಇಲ್ಲ ಕಳಿಸ್ತಾರೆ Zooming correct ಇದೆ ಅವರು ಪ್ರೆಸೆಂಟೇಷನ್ ಕೂಡ ಅದು ಮಾತ್ರ ತಳಕ್ಕೆ ಮಾಡೋದು ಅದು ಚಾರ್ಜ್ ಹೋಗ್ತದೆ ಹೌದು ಕುಟ್ಟಿಗೆಲ್ಲ ಚಾರ್ಜ್ ಇದೆ ಚೆನ್ನಾಗಿದೆ ವೈಫೈ ಹಂಗೆ ಕ್ಲಾಸ್ ಆಗಿಲ್ಲ ಅದು ಅದನ್ನ ಇಲ್ಲ ಗ್ಲೋಬಲ್ ಇದೆ ನಾನು ನಾನು ನೋಡ್ತಾನೆ ಇದ್ದೀನಿ ಇದ್ರಲ್ಲಿ ಬರ್ತದೆ ಕರೆಕ್ಟ್ ಆಗಿದೆ ವಾಯ್ಸ್ ಎಲ್ಲ ಇದು ಆಯ್ತಲ್ಲ ಇದು ಸೋಫಾಸ್ ಏನು ಐ ಡಿ ಪಾಸ್ವರ್ಡ್ ಏನು ಕೇಳ್ತದೆ ಇಂಟರ್ನೆಟ್ಗೆ ಐ ಡಿ ಪಾಸ್ವರ್ಡ್ ಕೇಳ್ತಾರೆ ಹಂಗೆ ಮಾಡ್ಬಿಡ್ಬೇಕು ಹಂಗೆ ಮಾಡ್ಬೇಕಲ್ಲ ಐ ಡಿ ಪಾಸ್ವರ್ಡ್ ಕೇಳಬೇಕು ಇಂಟರ್ನೆಟ್ಗೆ ಓಕೆ ಅವಲ್ಲಿ ಮಾಡು
You can start.
Yeah.
That is something. We'll start.
Okay.
So come back to the pharmacy.
Okay, good afternoon to all.
We are only in
I hope everybody is fully active after lunch. Yes. Okay, little bit difficult session. I think hope they'll keep us engaged. Yeah. First of all, I would like to welcome Geotech team and CEO Mr. Sundar Vivek. And also PFD student Mr. Prasad and Mr. Surasubramanian. Welcome all of you. I think they will also give us insight on the facade design. So I hope we can have an interactive session and also we will also learn more from them. Yeah, we will. Thank you.
Always the afternoon section is a sleeping section. I want you guys to make a sleeping. Next, we go through for the system, then we go for the practicality for the panels. We have already made for the panels for you to understand those panels, how is the unitized, whatever we are talking about for the portion in the afternoon. Practical for the what are the things you will be happen. Those for the unitized.
Mainly we are using Unitized only.
Yeah. Today I'm touching only for the Unitized morning people are already touched out. Unitized technology is the main area what India level, whatever people are using is most of them is for Unitized technology from Europe, it's for 20 years back, they already closed, now they go for a system, different system for frameless, cable, all those things. India also slowly they came up for the cable system. But come back to the high-rise building, Unitized technology is suitable. Here today we are talking about only for the new projects. We just want to try this one. This Unitized curtain wall. Unitized curtain wall with the pergola cable to factory for TMS system or luggage there we will be touched for the TMS system. Hilton is a contract hotel. Contract hotel is a 24th floor. There it's all Unitized granite panels. The projection what we look at the window, it's not a window, it's a Unitized curtain wall. I will explain to you about the application of the plant going to be works in the curtain wall granite clamping. Normally for granite clamping, we use it for the mechanical tools, not these elements. Those systems we back up. Then go back to that this portion. Similar one what we saw is the clamping system. Here it's a capping type. Capping type of granite also going to be affected. Okay, this topic actually most of them my colleagues earlier already touched. Pankaj as well as Mahesh, all of them they touched. What is Unitized curtain wall? How will we work for the natural facade? All those things. Facade, again, I'll come back to the facade. Is the facade, Mahesh has already proved very clearly for the skeleton to cover all those things. One thing we need to say that, the facade we can put all of them with glass all around the building to cover it out. use dead wall cladding as well. Where you need to go for a wall stick glazing, you can go for the granite facade. For whatever to the dead wall area, no need to spend for this panel glass, all those things. So we have to think over what are the systems where you are going to use. We cannot put glass everywhere in the building. There we have to think over where you need a glass, where you need for the solid panels. Solid panels you can go for a ACP or granite or dead wall with a paint. Depend on the budget of your, go for the paint or you go for the granite or you go for cladding. If you go for the granite, then granite, you need to think over for the lead pan as well. When you go for the lead pan, you have to think over what is your natural element around the element you can use for the like granite, all those things, your platinum value will go. Granite, all those things, natural element, where you go to recyclable. You can use any movement of aluminum, you can melt, all those things. So you will go for the more of them is recyclable material you can use. Go for the platinum, all those things.
So if you go for granite, you will lead by
Yes.
instead of glass.
Yeah, instead of glass also will come. You go for the granite is a natural because you are not doing any processing. So you are just using a natural element without what you call. It's only give a cut and utilize it. You are not made a mill or anything. Wherever using a granite, you just take a natural stone, you cut and use it. Only for polish. Okay, normally what is going to happen? For vertical element you want to do. See, the building always has slab and the column, all those things, we are going to form the element. So the curtain wall, we just make element to cover. Okay. Where are we going to for the cover? As the two things we need to look out for here. So, morning, my friends already told that what is vision and spandrel. Why we have to put the spandrel? The spandrel is nothing but where you are going to use for the slab to cover. And second thing, whatever your building maintenance, if you go for the fire hydrant, whatever you go for that plumbing or for whatever you go for the air flows, AC, duct, everything, you should have to be covered. Okay, normally if you go for any room, if you take it out, I cover by the ceiling, all the elements will be covered. You have to cover. When you go for cover, this is the spandrel item. Slab is here. I want to cover the slab. Plus spandrel panel. You know the spandrel portion. The vision, you need to see through the glass. There is called the vision. 900 mm, what we are talking about, from the FFL, always go for a 1.1 meter 900 mm, introduce a transfer. You already go for the curtain wall, you may have different types, stick glazing, unitized, we go for ribbon glazing, all those things. We have an exterior screen building, we have to think over where you need a panel. You are going to have a height of the building. Example for 3.4 meter height, that is your slab area. There you will introduce your spandrel panel. Derived by whatever the interior, your height, ceiling height, whatever is good for your AC duct, everything will be impacted. The spandrel panel will decide what is the height you need a spandrel panel. Is it sufficient or 600 mm is sufficient or depend on your structure in the back side. Okay, we have a different type of thing. We talking about the frameless. Frameless, we are using a spider type of things. That is a glass tube system, cable lid system, spider bolter system, tension truss system. Tension truss system is nothing but we use a huge elbow truss with a cable to push it up. When you go for a framed one, is normally called window. Windows are nothing but we are using for our houses. We are using olden days with a wooden frame, aluminum frame, and UPVC frames. We go for the curtain wall, we have a systems of different curtain wall systems. There already we test, I don't want to go stick system, unitized system, and semi-unitized system. These three systems. When you go for windows, there we have a type of windows also. There is called a strip window. Punch window is an openable window. Strip window nothing but you need a continuous of the window. You go for one strip of window, you have a slab and a beam. In between you have a strip to continue. Punch window nothing but all around the structure, where you have a structure all around interfacing, that is called the punch window. Openable as is closed, wherever you need an openable. Design for openable also is a criteria where you go for residential and commercial is a different criteria. If you take it out, then we go side on opening. Commercial normally go for a top on opening. Top and opening only a restriction of 300 mm openable. Why the 300 mm to 170 mm? There is a restriction of playing kids, a ball or anything should not thrown out to the high-rise building. That's why the openable always restricted 170 mm. Not only that, if you open up the full, you cannot hold the handle again to pull back. The chances of falling down. So 150 to 200 mm, that is the open. It's a stick to follow for the commercial building, not the restriction. Okay. Now structural loads taken for the frames as the load structural loads only for self load only. The curtain wall will not transfer the building weights. For the curtain wall loads itself and additionally taken as a wing loads. If we go for the curtain wall. Glass acts as infilling material. So we know aluminum is the element to frame that because glass itself will not stand. Curtain wall, you have a frame to element. Example, if you could look for the any element, aluminum frame is a supporting element, like a photo frame. The photo frame will go for the photo, all around you have a wooden structure. Similar manner, the frame will be taken out the loads. The glasses which stand sandwiched in the panel. That's all. Stick system. So I do this system is pressure plate capping system. It's a normally we use in the olden days. Pressure plate capping system. What we do, Marlin transom. The Marlin and transom, normal pressure plate cappings, we use it for the fixing. Again, we go for the transom. This is for the head transom. Transoms, and where you put the seal, the bottom will come to call is a seal, and in between comes vertical margins. Transoms. Whatever the horizontal members are called transom. In the similar manner, you go to the unitized curtain wall. This is called vision transom and seal transom and head transom. The transom and margin. This unitized system, as you know, that we have to form the frame and look like fabricate like a window. Each glass has a window type. You have with the clips and screw back to the original frame. Doing their partial doing their factory, partial doing it side. This is called the middle is the both. Unitized curtain wall is comparing with all these two. Unitized curtain wall, India we are using more of the projects. Unitized curtain wall. The unitized curtain wall speed will be more, and the bracket everything will be installed at site. The glazing is a complete element come from factory to come out only for the like children's normally is a Lego toys. Similar way we are coupling here. These were used for the angle bolt. The alpha channel is wherever the PTs buildings are kept, there we go for the passive channel. But it will be expensive. But when you go for installation wise, anchoring in the PTs is quite complicated. We should not touch the PTs. That's the reason we go for the alpha channels or anything. Branded what we call alpha, you know that also they recently they come up for embedded channels they call.
So what is the disadvantage? Generally, even the alignment.
Yeah, because what happened with this one, while the concrete tank you have to install this and to maintain it. The vibrator comes should be have to be made a template. So the position should be the perfect. The position is to change or invert with the concrete, there will be the difficulty will come. So the maintain at the site level should be better coordination with the concrete people where it comes there in the concrete should not be made and should not be damaged. It's not like a dipper, you can push it out and bring it out. Okay. And the condition of here. This is called the alpha channel bolt. So what will happen is bolt once it goes in, stand back to the, it will get locked. And this goes in, it can move anywhere. What will happen to this? In and out, I can give the start bolts. And when you go for this moment, already we have a start bolts here in the channel. You can close. We normally go for the corrugated type of things. This will go for stop on the in and out movement. This is for aluminum bracket. Normally, we are used for the steel brackets and using for steel brackets.
How much maximum tolerance?
This one, sir, normally it's a standard construction tolerance plus or minus 25 mm. To go for in and out movement. And vertical movement of plus or minus 50 degrees.
But here there is no smart for vertical.
So,
Vertical, how will adjust in this, right?
let me come back to you.
Okay.
See, this vertical movement, what will happen here? This flat hole, it's only under steel. When you come to aluminum, you have to drill it side. What you come to the mullion, see, now we understand that this is going to be a dark flow. Once you tighten up, you have to go for a certain strength to go flat. Okay. So this is my male-female mullion. So the same system, what you see here, the small element will bring it here. Element will come. This is called a male element, always having a link. Male and female. This is as one unitized curtain wall, always having male and female, silk transom and head transom. This is a complete as a one unit. Formed in the factory, the glazing will come on the top to infill. For a side condition of male and female full unit, it will be like this. So the curtain wall will come together, the silk transom and the below closer to the bracket where you have to drill at side. The position is maintained, everything at plumbing, everything will be perfect. Then you have to drill the mullion, then you put the bolt. This is the area. So where you need to put the bolt next, tighten back the back.
Vertical is not there.
Cannot, sir. Until you wait. See what will happen now. I have installed this curtain wall. If you look at it, I always supported only the male side. The female side. I always, any system, if you take it out, always is supported only for male side. Female, when you go for the female side, always the transfer loads will come. So what will happen for the connections of here? Once I connected the two curtain wall, the transfer load from the female side, it transfer back to the male. You assemble it. Okay. This is the male mullion. Once the female mullion comes, the unit. Once you engage here, the leg will be goes inside. It will not allow the female mullion to go down because the head will be sitting on the top. Then again, the gutter sleeve on the top. This is called a gutter sleeve. This gutter sleeve will transfer the load from the female mullion to the male mullion. As you said, the four-way joint, why we needed for the vertical movement, where is the horizontal movement we consider? We in and out only consider where we come out from the vertical movement. So the four-way joint normally we call is this portion, where we connected all together. This is the portion called four-way joint. And this is the head and steel. If you look at it here, see what will happen for the head and steel. The top portion, as you said, it's connected to here, transfer the load with the gutter sleeve, just pick it up. And this is for the thermal insulation where we need to go for the filter. Because what will happen? Engage on the top, continue from the vertical, you will continue here. So the movement of the four-way joint, just see here. The four-way joint of movement. Okay. This portion, if you look at it here, as again morning is taken as no wet area and the dry area. This is the called as the wet area, this is called the dry area. Where the element is close here, gas filtration area. This is normally called the ML portion. Slab defect, example for the vertical movement of down and movement, this portion will go up and down. Because if each member, if you go for the vertical movement, it will be comes like this actually. Head and seal will be go for this portion. Similar head and the seal. EPDM is in between. It will allow to move. Whatever the wind flow or thermal movement or anything, 1 mm or 2 mm, it go up to 10 to 15 mm will move. Those things. Similar manner for the horizontal movement. We already have a horizontal movement of a start pole, but still go for a thermal movement. We go for this portion. Male and female also is open channel. Because we always connected the male mullion, female mullion always is open. So what will happen? When it's open and closed in this. You notice this EPDM will cover for the leg to move. There where we taken up the unitized and involved, switch totally towards the okay, where we have to install these brackets, similar manner, different condition. Seal at the bottom, subseals at the bottom, similar manner. This is a subseal. Factory for unitized assembly, the factory. This is a 15 log where I need to 50 panels.
Vertical movement and horizontal movement, is there any standard norms available or it differs from system to system?
System to system, sir, but Indian standard is go for plus or minus 25 mm for the movement.
Both sides?
No, 15 mm.
Both X, Y axis?
Yes.
Okay, each side.
This depends on the system. If you go for unitized angle, 5 mm also it comes. But every 1.5 meter or 1.8 meter, 5 mm. We take it up 3 meter, it's already 15 mm is covered. See, example, what Magesh is telling that this projection of unitized curtain wall. So what we do, this is one type of curtain wall where we go for a element, only projected of the curtain wall. So the head transom and sill transom will be the same. If you look at it, the next head will be travel out and continue for the form. The second one will follow this. Again, go back to the original. The head and seal only is playing the role for the curtain wall. Okay, where we saw the male and female, this is the portion. And the EPDM is member to control because any movement of material movement, we will make a noise. When you come to the EPDM in between, it will reduce the noise and allow the movement of field. This is called the head and seal transfer, nearly closer to the slab area, where I have anchor, everything, normal horizontal channel anchors we use. And this is the bolt that we use. If you look at it, this is a ring hole and air hole we use. The spandrel panel, normally we use it for the vision glasses for DGU, spandrel panel for single glass. This is the one for single glass, and the shadow box for morning is introduced. Shadow box. This is called as the shadow box. Shadow box, nothing that you are protecting the view for this slab. And creating architectural element, you want the band. What kind of a band you need? A blue band or white band in your building, or coincident with the glass. This kind of element we control from here. This is called portrait backband. Whatever color architect you choose, there we need to build. This is called a special corner mullions. Normally building turns 90 degrees. The 90 degree area where we need to have a unitized curtain wall. There we need to continue. Here we introduce for the corner mullion. So in this corner mullion, in my previous company, Thomas Lisa, we started designing this portion. Now India, everybody is following for a corner mullion. Normally it's a single piece. This is a split mullion. What will happen? A 1.2 meter or 1.8 meter of individual curtain wall will come to the corner also. Will continue the same. Corner curtain wall will come and continue the system. So normally what will happen in the olden days? They continue for one piece and put the box section in between. The corner as a one piece will come. So here what will happen? We split the mullion and connect it together and continue. Sorry. Yes. That's why you need to go for a solid. Actually, wait. See, here you you need to think over for also. If you go for a glass at the corner, normally we should avoid it. Building maintenance unit or cleaning guy, anybody will come. The weaker point in the curtain wall is only the corner. The glass. It can hit easily, glass will break. That's why if you look at it, any system, the glass will not expose. If you look at it, glass will not expose to outside. The corner should be protected. Even you go for a corner piece also, you introduce a box section here instead of glass. There you can protect for the glass. So normally people will like, as you said, I want to look like a corner glasses, very fine, but glass will break easy. Even your handling time or installing, you go for the handling, or after installing for a cleaning guy, easily one hit is enough for corner. So normally what will happen when we are the designers? So when you come to the corner portion, normally we protect, will not expose the glass edges. That's why the design makes. We convince architect many times, they will come up with glass, I need a corner point, everything. But we need to explain this problem. When you come up with a maintenance wise, this will be the good. Glass edge always should be protected. Okay? See here, I just want to say that in the morning we started for loading platform, all those systems. Okay. Here I want to touch with you all is a monorail system to install the panels. So normally the installation method we using a different system because this is all hotel room. Every rooms, if you look at it, it's an individual room. We cannot travel that each room is around 3.8 meter, 3.5 to 3.8 meter. So individually you have to travel room to room and movement of material and system you want to add floor cranes or anything you design, it will be nightmare because every room you need to shift all those things. So here we introduced called the monorail track system. If you look at this portion here, can you go back to the project? If you look at it here, this is a car, like nothing much using a special IBV and with the monorail track. Okay. What we do here? See what we look at here. The loading plan, whatever the cutting walls here, I need to go back to this portion. So we are using a special material. We need to have a lift. The curtain wall using as a lift to go back to the position and travel to the correct location. So what we introduce here, we using a small string to make it out the panel. Because otherwise, what will happen? The wind flow is more, and this building is 24 floors. Nobody will going to hold the panel by hand or anything. So we are using a strip rod and make as a lift to lifting the panel. So what will happen? Lifting the panel, and here what will happen is monorail key will come back and capture this and travel to here to drop it. And similar manner, what will happen? This loading platform will come here, goes up, taken up, drop. Goes up, taken up, drop. So here what will happen? You don't need to use every room as your floor cable to install. So what will happen? This travel will reduce my time. So this system, it's not for the project to project. You need to think over how to lift, how to come up to the location, how will reach the curtain wall to that location. That also matter. Which system you want to use? A floor crane, or you want a loading platform, or you go for the different element. So what will happen here? In this project criticality, go for the loading panel. This is the third floor. So we have to shift the panel to third floor. Photos. These photos. See, go back. See, this is a one area where the swimming pool area. This is a loading bay. So what will happen? The tower is started from here, above 3 floors. But if there is no other access to come up to the tower. So where we design it, special equipment, shift this panel to go on the top, like a loading bay. many levels you have this model? What is the how many levels? See what will happen. We have to design such a manner of 10 floors. For each 10 floor you have to keep. Depend on where you need it. Because normally what will happen, the string will come to 10 floor is better. See what will happen. In this condition, we need to go for the different monorail system. One need for separate monorail for these, because where this is a granite, I need to demand. Another is glass. Glass, I don't need to wait for the processing guy to come and granite to take all those things. So glass, straightforward will get it. So the team will be different. So what I do, the different monorail. One for the monorail for these, another monorail for separately for these. So what will happen? If you look at it, this curtain wall is a glass curtain wall. It's easier for them to go for per day of 50 panel, 40 panel will go. This is only for 12 panel or 15 panel. So depend on the speed. So we only do the same monorail only, different motors for the different team. We go for each floor. We go for here, another one for here, another one for here. Three teams we can work together with the same idea. So when it comes to this portion, the monorail is closed, then we need to go back to the above floors. There we need to go for the shifting monorail. So what will happen? 10th floor, again 20th floor, then the terrace. This is the methodology where we need to go for the monorail to play. Okay, here, go back to the demo. See, come back to this curtain wall where you know from inside you can access all those things. When you come to the dead wall area, we have a special design we need to go. See, this is a dead wall area. If you look at it this way, nothing is there is no room, but they want to have a client. I mean, when you come to the from client, what is it that I want? The granite, but they will not put a scaffolding to the whole element next to that, that busy traffic area. It's also corner. So there is not allowed to make a scaffolding for the whole building. So what will happen? We made a unitized curtain wall. So unitized curtain wall, what will happen? You need to have a two location where you need to have both seal and head to work. Go to the next one. Go back. Here. Here. There we use a double-decker gondola. See, this double-decker gondola is nothing that the normal gondola only. So what will happen is this curtain wall is 4 meters. You have to do one at the bottom, one at the top. See, this bracket when it comes here, you have to work at the head transom as well as you need to go for the next head transom. Seal and head, the people need to be stand. Then only you can install this panel, the correct location and put the bolts. So what will happen? The double-decker gondola will solve the problem like a floor, but it's the opposite direction. See, like this. So what will happen? The guy will come from the bottom as well as the top. The curtain wall will close. Similar bracket, because there is no inside access, only for external, double-decker gondola, dead wall area with the unitized curtain. Okay, this is called as a lifting block. Any curtain wall we need to lift. We cannot use aluminum to lift. Aluminum we cannot make a hole, we cannot directly do lift. There you need a steel material to lift the curtain wall. So I need to lift the curtain wall, I cannot carry only the aluminum. I need to strengthen this aluminum using a steel member. That is called the lifting blocks. The lifting blocks, what will happen? This will be captured with the screws. But all the bolt nuts will come on this steel. So the element will go on the top with the aluminum member, but I am not making direct pulls. We are using a clamp, mechanical clamp. This is called a string. What will happen? People will think that aluminum just drill it and keep it up on the door. 20 floor we need to carry with the aluminum, it will be here. So there we need to have a special rope, all those things like clamp, and especially we need to design the hooking track, everything we need to design to lift the panel. The lift the panel and just the panel, everything will be considered to when you design the panel. Not only window. So one more thing. See what will happen? The projection of the building. Whatever you want to project, one 1.5 meter, 2 meter, 3 meter, it's not necessary you need to project a concrete along together. Not necessary you need to make a steel frame. So the projection, you don't need nothing. Just look at this portion. These are all the elements. Nothing there. Go back to this portion. Go back. You build it. Go back. If you look at this portion is 300 mm projected from the container. If you look at this portion, there is a 300 mm projected on the curtain wall. Total curtain wall is projected from the glass base. It's 150 granite steel. So there we have to think over how we need to make the plan together with the curtain wall. The curtain wall is together. See what will happen. See, anything we're going to procure the material, unit curtain wall, what we have to procure the material, you have to plan for the cash flows. Because we cannot like the system, you buying the material and doing it and waiting for the next material. Here, procurement is a matter. See, the zone 1 material is coming on the bottom portion. Example. See, example. See, what will happen? The cash flow is the main area. We are utilizing from the client whatever the money they pay. So, zone 1, we need to spend the money. That is the bottom portion. When the zone 1, I will complete here, it comes here. When we deliver, I will get the cash flow for the zone. Zone 1, when I go for this material to come up, you know that we need a minimum tonnage to maintain the material. So, zone 1 and zone 2 and zone 3. So, what will happen? Zone 1 material will come. I can continue for the work. In the meanwhile, client, whatever the payment comes, zone 2, I need to invest. So, what will happen? Directly from zone 1, zone 2, zone 3, zone 4, you can give the clearance as well from the site condition. What will happen? I will hand over for the zone 1 and go for zone 2. You cannot order the material for zone 2 instead of you are not paying for the zone 1. Procuring material, plan, maybe the different height and different thing. The zone 1 material we need to plan to continue to for zone 2. That is what we call as a planning. Planning will go for every zones. When there's a non-priority zone and priority zone, first you need to do the site and go for the element like staircase, all those things, non-priority area. And decorative area is important. See what will happen? The building is what it is important, go for the decorative. Decorative is called as the topmost pergola, sunshade, is all as a decorative element. You can hand over the building, then you can do the decorative income. That is called decorative. That's why always the decorative elements will be the last zones. Okay, here execution flow. I'm buying the granites. So what will happen in the granites? Each granite will go for a special element to make a clamp to hold the granite. If you look at the panel, example. See, if you look at it here, this is the panel at factory. Whatever 300 position you saw, everything has one element to fabricate and as a complete one element. When you look at it here, each granite you want to install, there is a clamp. Each clamp you have to screw fixing, everything to be done at factory level. See, instead of doing in the vertical level, doing in horizontal level always is easier. And maintain whenever we design, this should be anytime if need to be replaced it can be do it at site. That's why we need to design such a manner it's not only with silicon clamp system, it's easy to replace it if anything is happened. This way, how they do it for the two type of loading. One is for the horizontal stack system, and is the vertical stack system. Transporting these many elements, we go for the fabrication as you asked. Assembly at site. It should not be done in assembly at site. Because of structural silicon, you need to apply that dust-free zone. Because what will happen, even a small molecular or we go for changes, if we go for sand mixing, or proper chemical laboratory to test. So normally what the people are doing, even a structure silicon, the warranty given for galvanizing or GE or anything, they have to test in the laboratory. That whatever like a concrete body do it, so compressed test, all those things. Similar manner silicon also. Everything they do for a butterfly test and they go for adhesive test, everything will be. And everything will be recorded when you go for handover to the client. This way we have to go for the unloading element and go for the proper numbering. So the numbering is a major role. So panel numbering. Unitized curtain wall, everybody knows unitized curtain wall. The panel number is important. Whatever is called male female, everything is male female. The whole system is male female everything. But depend on the sizes, depend on the design, and depend on wherever the floor is coming. There we call as a different numbers. Like a car manufacturer, normally they fabricate as a 1,000 cars. 1,000 cars will not be the same number. Every number, every car will have a different number. Similar manner, I need to track on my production report. I need to track my day when I completed this panel. I need to go reports. And even though CW1 is a one type only, in the CW1 will go. Same car, if you go for a car, Hyundai, you buy one Hyundai car, the Hyundai car is Hyundai car only. You go for whatever it gets, the number will be different. And the manager motor is different. Similar manner, we need to maintain as each element, each export separate for each one. This is how the completion. We are using a special LED lights in every sunset element and go for the projection. Any question? Then we'll go for the glass. Actually, what happened? Actually, today there is 3 presentations we have planned. One for this, second one is for the testing element. The testing element I call for visual testing guy is not here, so I'm continuing for the visual testing. Go ahead. Not video. Visual. Actually, the beam wall, say I'm a consultant for beam wall as well. So in theory, I'm doing for my offshore for beam wall because India, the testing is the most critical, and there is really only one guy is doing in Mumbai. So I worked in 10 years in Singapore, so I know beam wall is very much. So I personally involved to set up this element in Chennai. So earlier, in India only.
Mumbai and
Chennai. So only in Mumbai, Prasad India. Yeah, that is a monopoly. So when I came back here, I was very surprised. Only one member, and he will decide who to be, who to be. So when we come back to here, see what is like, we need a competitor to fight. So we created actually what happened every time in Thomas Laser in Helium company, we have our own test element in Thailand. So in India, it's only one guy is doing a testing. Always we'll go back to Bombay only. So why we cannot do it in South India side? So we go and approach from the Bengal. So they agreed to invest into that Sri Lanka. So finally, I convinced them come to Chennai. It's a good place. We need to come back. So finally, they set up. And one of my friends
very important is, I mean, we have to do before we start the work or which stage we do this.
Yes, I will come back to you. So, why a performance test, where, when test? So, the system what we design, is it suitable? Example, I designed that building for 10 floors. I cannot to take any mistake has happened should be taken out before we started the building. I should not have done that after 10th floor I completed hope. I made a mistake. There's nobody will get a help. I cannot introduce any element. I cannot increase the thickness. I cannot modify my design. At that stage. So what we do? We have to think over what we require. What is the system you require? What type of a load you require? Those elements will make sure the system is safe to go for 10th floor or 20th floor, whatever you need to. Evaluate the design. The design, whatever you need, whatever sunshade, whatever you do, elements, anything, whether we withstand the wind flow, whether we stand for water leaks, whether we stand for the sound proof, whether we stand for anything, deflection and changes. Fabrication error. Small mistake will happen because small level, what will happen? Fabrication, they missed out some element of silicon, all those things. When we tested, everything will be captured. Rectify all faults before final production. Yes, you have done it before starting your original job. Then save the cost of time, because what happened, I learned the mistake after 10th floor completed, and I did a mistake, my boss will pick up. I cannot say that, sorry sir, I made a mistake after I completed my 10th floor building. Sorry sir, it will not work. Then nobody will accept, client will not accept. So we need to say everything save on cost using even a small money you spend, but I have to test it completely. Quality of facade, yes. Okay, you can do that as a two method. One, you already done at my site, I want to test it at site, or I do it in the laboratory, where you need to create that cycle, and you need to create a rate. You need to create access to speak. Everything you need to create. You cannot create a site condition of system. You cannot create an element to close up to confirm everywhere wherever the problem is comes before we starting the job. So you need to measure the deflection. So they need to have a laboratory. There where we go for the laboratory to test what is the movement of the facade, what is the movement of the glass, what is the movement of leakages. Normally what will happen, air infiltration test will confirm that how much leakage in the system. The system is there is a air leakages. So normally work on site, check workmanship on site during construction. Only for inspection only can possible. You can do only the final water test only. But this make sure to follow. Okay. What we do for air leakage infiltration? Normally what we do? They will do the facade. They develop the facade. 2 floor or 3 floor, whatever the specific come. They create the facade, and this is called as a chamber. This is the chamber. On the chamber, the curtain wall, whatever you have the air filtration test, they put a plastic cover. Total. They put a plastic cover and they suck the air. What will happen when they suck the air? Wherever the holes are there, you get blocked. Because the plastic paper will be there. Then they remove the plastic paper. Again they test it. So wherever the leakages come from the curtain wall, how much percentage will be allowable? There also specification will be there. Water penetration, same manner. What will happen in the curtain wall? They spray the water. They creating the rain. And they creating the rain as well as they need to make us air infiltration also. So what will happen? A small hole. The calibration test will normally will straw. If you use that for a straw, normally what will happen? They use that and suck the air. Similar manner, you need to suck the air when you throw the water. So what will happen? A small hole, we create a big problem. Now the condition is only for negative pressure only it will happen, because in case of heavy wind and inside you have a AC, the calibration will start. So what will happen? The small hole will suck the air and water. So then they go for a dynamic test. What is dynamic test? The dynamic test in India there is a 2 ways. One is for dynamic, another one is cyclic. Cyclic and dynamic is the same. What we do is that there is a propeller. They are using that to make a dynamic for the heavy wind. Suddenly we need a compact impact. Cyclone when it comes is not only the constant flow. If it comes, suddenly we go for high and low. So that kind of a dynamic really creating here into the facade, along with the water. Yes. Structural performance. Yeah. Go back. Yeah. Yeah. there should be the ASTM standard will be there, sir. There should be there. The American standard will be the using. Normally for an Australian standard, they will work for cycling. The cycling, what will happen, they will closing for the damper every 30 seconds. The damper will be closed and open. Full pressure of 1.8 kPa, they open and close, open and close. So what will happen, they will be creating from here. This is for external. Normally Australian standard will be internal. Structural performance, what we do, this is where pressure, what will happen, instead of 1.2 kPa wind load, they will go there. Here, they make a dispersion transducer. So normally what will happen, if any movement of Malian comes, how many mm it moves and come back. So what will happen, we designed a such manner of how many mm is moving. There is having a pneumatic element will be supported in the back. So when we go to the air flow, this curtain wall will start bending. And the deflection of the glass 19 mm, it should be 19 mm. If it is 1.2 kPa wind load, they created and the glass will be deflected. This is a sensor. So what will happen? Once the sensor will attach to the transom, this is the position. So each point is the position. If anything is movement, it happened, this is all interrelated with the computer. If 1 mm moves, it will read it. 1 mm is out. So in that manner, so what will happen? If they are going for the wind load as well as for the ring. They created the ring as well as for the wind flow. This movement comes in the aluminum and the glass, all the areas. This is called the seismic for the movement. Normally, what is the seismic movement in India? Nowadays, only they tested. So this is the seismic movement. They take it as one floor. They move the floor. Move the floor means it's only the top IB. It moves in the location of 15 mm, right, 15 mm left. The seismic condition. So what will happen? This floor of this curtain wall, I move this, not moving this. I move only from one location. This is as using for the roller. I'm using a hydraulic jack and move this 10 mm and come back to the 10 mm. So what will happen after 10 mm is moving this side, come back to the 20 mm. 10, 0, 10. Again 10, 0, minus. Okay, normally what you will offset resistance we all do it here. Impact, thermal cyclic, acoustic, everything we will do it here. Water leakages. After that comes to the site condition, they will go for the water leakages and leakages. That's where we go for this site, we go for this kind of a place. They are using a special nozzle to spray this in, and wherever the location it goes, vertical element or 300 mm away, they maintain and use it. Same thing goes for the skylight as well. Pull-out is normally BTP doing, even the Winwall also is doing for like external party. We think Winwall is doing for American standard, Australian standard, and British standard. All of the standard will be according to client requirement. We go for any standard. We don't have any Indian standard for this facade testing. PST. PST.
Yes.
The testing. No. There is no complete thing. There is a HAMA standard will be there. Normally will be. They are only for windows, not come for the facade for specific unitized kind of work. Dynamic water, whatever is being given. You have to create a cyclone. That's why whatever the water sprayed with the air, you have to create that wherever small holes are there, there should be a capillary reaction. You take the suction, you need to have a suck the air in the inside. Whatever small silicon, if you apply, it will come out. So normally Winwall is doing for element in Chennai things. They are doing for all over the districts. See, what is the minimum they need to go for two height panels? Height in the two panels compared to the lead schedule. One is must be in the floating. Three panel, one is must be in the floating. There only we can able to test any kind of a shape. So you have to choose that which area you want to test. As Mahesh has mentioned, the corner area always is a critical part. The dynamic, the corner. So you have to choose that portion. Corner. Choose that portion. Typically, you want to go for system. All those portions you have to decide at the site requirement. Any type of things. Because the chamber is that if you go for a 30-meter chamber, you can design whatever you want. According to you, they will be modified in the whole structure. So the common failure, what will happen? When you test it, normally what will happen? So when you go for this kind of a thing, the window area, so the reaction when you come to the suction the air, no? The air and suck the water to come up like this. Because to suck the air enters inside the building. The water will become a small hole. Small thing. Because all over the window, this is the biggest point in the facade. Substrate. If you miss out on any silicon, you see here, a small giant of silicon being covered. What will happen? Normally the people will do that in the silicon will cover the water tank. No. Should not. If you do like this kind of things, you see this, it will come up. But what will happen? You are suctioning the air and applying the water, easily the silicon will be used. If you made any without silicon, if you look at it this kind of a position, the water will come. Structure failure. See, normally what happened? Every test we done it, they will ask, what is the proof load? Because you already done the design. We need to know in our cut and wall what is the failure load. How much I need to make this system will be failed. So they need to apply that goes to the end to failure. Then normally what will happen? 1.5 times is the design calculation already we consider. They need to go for a more. Even the 1.5 times, plus we need to go for until to failure. So normally we will go for 2.5, 3 kPa. We go that's the glass and openable will fail. This kind of things. Is the normally failure and the openable panel. Multi-point lock, there we will start the failure. Sometimes the mullion will be disengaged. What will happen if you put the more load, mullion will be disengaged. Bracket can be break. Whole hook on panels can fly away without uplifting area. If the hook on panel, whatever a hook on panel, we need to such a way design that uplifting bracket. The uplifting bracket will stop the movement. If without uplifting bracket, the panel hook on panel will fly away. This is standard. That's it. Then.
So this one I asked question. I from this level to generally you start direction. So then you start the production.
Yes. Theoretically, yes, sir. So India is actually what I said. India is different thing. Family production also as well as administration. Theoretically, you need to go for approval, and the test is passed. Then we need to procure the whole material. So normally, what will we go for a we go for this portion, no, then tested pass, then only it comes to you.
What are the cost of the test?
Sorry, sir?
Cost of the test.
Cost of the test is depend on what are the element performance. So this depend on this. Normally, what will happen? 4 panels of the hose, example, they for 20 to 25 lakhs.
25 lakhs, 25 lakhs.
How many days will it take to?
Erection is 1 week is a process. They will give a rental for minimum 1 week. So in this 1 week, you have to install your panel and go for a testing. Normally for 1 week time they'll give for the panel installation and wait for 3 days for silicon curing and after that we test. 2 weeks. 1 to 2. So but if you go for a testing, the fabrication, everything you have to done, you need to book that. The normally test will not, laboratory will not be free. You need to take the location, what is your size, and you need to book the location. Otherwise, what will happen? Other people will come for 20 meter, then you have only for 5 meter. If you design for 10 meter, you need to wait for the timing.
What happens that Winmar, there is a testing facility. So they will, for the contract, they say 1 week you will complete. They will give for rent for 1 week. Within 1 week, that whoever the contractor, they will come and fix it, everything they will do. They have to complete it.
The contractor has to go there.
Yes, they will do. Contractor only will do.
Contractor only will use because the system is designed by the system vendor. They need to come and install their product because you are the
You will
witness.
make a building, they'll give like a steel building.
See what happened? We cannot make a concrete building. So what is your floor? They will adjust the floor because in this laboratory, whatever you want to adjust, you can adjust. You want to adjust for 4 meter or 6 meter or 10 meter or 3 meter, the floor will be adjusted. And you need it such a way that you need a whatever design is suitable, they need to suitable for the floor, the movement, and the model of how many panels. And they cover that portion, they make as a chamber. In that chamber, wind wall, minimum I think 10 laboratories there inside. Then you need to create each 10 member per, parallelly they will work. And I very sure whoever is interested, just after the presentation, you come and look at it, what is the joint area, because it's very difficult to
After the presentation.
And we made a individual expression, how it will look like.
You will take it back or it is for us?
Not for you.
Actually,
You can ask actually all the contractors supposed to submit this.
Sir,
You can ask them. They have to submit this sample at the site. All the
sir, you know why we are doing such manner is actually in geometrics and luggage, and we train one college students. Every year we train them specifically for facade industry. So in Rajapalayam, we selected the college. Those 2 students where they came research from their there we train for the students. Totally 170 students in this market all around is there. I can proud that I can say that wherever which company I take, my students will be there. They are in this field. They can choose their own. And so we continue for the last presentation. Please. Yeah, they can do so. Another normally will come for the material instrument and we instrument and look at how much this thickness will be the can. Natural advertising and what color you need, where you will meet it. There is a complication. Analyzing, powder coating, PVF, all happening. Yes, there is some video for testing things. Just like
This is a test.
what is the next one?
What is the difference? Full test?
No, it's a performance test, not Winmar factory for Neta.
See, this is the movement.
Whenever you measure, whether to move, you see how much it displays, how much
Displacement, how much is happened, you need to read. Going to the water test. Same thing for the glass. Small clips is there. This is the reading. You are going to be creating that dynamic things and spraying that water and applying it.
standing inside also.
Yeah.
Normally, what do you know?
Today, Vaskar is there, I think. Right? Vaskar is there and stepping for again.
This is for UPVC video. I want to see. Satish. Technique. UPVC for technique. Do the testing. Next. This on site is go for the real. How much pressure is here? Pressure. This one, that's it's kitty.
That is a limit.
The rain would lead it to push. Self-draining system. Yeah, self-draining. Self-feeding. So it's a dry bowl. Dry drainage system is nothing but where there is a deep hole and deep hole. It's not expanding. Internal portion. This is the portion. Wet portion. This is a wet portion, this is a dry portion.
See, bigger sunshade. So, whatever testing, they have to do with sunshade. If there is sunshade also, we have to install. So, that testing, they have to do as a complete.
Sir, and here I need to get the
Performance in this area.
What happens
Performance tests.
during testing time, sir is not accepting the sunshade. So he asks us two people to walk and jump over there. So he sent my team to there and physically with that they have to jump the sunshade. All the testing is done. Unofficially, we done that test as well. To physically to people to walk.
So sunshade for people to walk.
No, sometimes they will step in, right? While maintenance, the step in is not found.
We tell them, sir, actually, you know what I would say, practically, say, Tiwari saying, no, all the testing is okay, I want people to jump on the sunshade. I'm telling sir, there is no code. There is no code to state that jump on the sunshade. So we tell them, okay, all the videos switch off and ask them, two people to go and jump the sunshade.
So customer satisfaction.
Actually, not only that, see, the original sunshade is a full solid. See, the original sunshade is solid. So they propose other one with a gap in between. Okay. So that is their.
Yes, there is a gap and how will it track as a sunshade?
No, that's why you have seen the thing. It's like an aeroplane. It's like an aeroplane. It's slatted. You're right. You can see that they did this. This is like a whole.
How many parents are there? Sorry?
2007.
2007.
Have you read the heat show test? Heat show,
Heat show test. Heat show test is the glass busting.
That is for the glass.
Yes. Have we done for that?
No, not that. See, normally people won't do.
Heat show test is not at site.
What is the factory? factory. They will do a factory.
Heat shift test. See, normally what happens?
Heat shift test.
See, normally heat shift test is nothing that 100% all the glass will be infected. Heat shift test, what will happen? 100% you need to test it out. The sulfur content, whatever it comes here, you need to be come out. So you need to make a sudden heat and make it out the tube. So in case of a metal particle inside the glass, when you go for a sudden cool, it will not deform. So it will break the glass.
We know it. What happened in that case? The 30% glass may break. So they will charge.
Sir, not me. First.
It will break. No, it will break.
No, but
Now they will charge you more. So people won't do that. What they will do, they will do 2%. They will be saying tomorrow, future, maybe what happened. Suddenly it will get cracked. So they will replace them.
So rather than doing it,
30% glass, they will do like this.
so there is no percentage for that.
There is no. You cannot determine how many percentage will be go waste. It may be 100%, it may become 50%.
So what are the tests to be carried out at site level?
Yeah, so I'm going to cover it. So they are not covered. See, he said, everybody will sit the water penetration test.
One is the water.
Say water penetration test, pull-up test.
Pull-up test.
Which I have the list. I think I shared out. I have the list. What are the tests?
See, normally what will we did in the KOP is a gazebo. This color is a special gazebo where I went for the seat owner house. So they want to have a concept that they want a canopy, so they want to have a gazebo type of come. And the concept is they want to take from that the flower pot. And if you look at it here, these are Muslims people, the Makkah. They will taken the concept to come out to direct. They want to wake up in the morning, they want to see that in the land area. This is a gazebo. We have to form this. They come out with a gazebo display. So each, if you look at it, it's a lavish DGU, but this pattern will be there. So we need to read for the different people. See, this is the pattern will come. So we assemble and all together, the gazebo will be come to this kind of a pattern will happen. So why I'm showing you this should be as a part of the class. We can come up in any entrance area or anything. We now India will come up with this kind of things we need to form. Either you want about Rangoli or you want to have anything in the front area. This is also
But Rangoli is already finished.
yes, it's not tested. Each glass is patterned. That also it's a filtered, glass filtered. Glass filtered. It's a melted glass. Go back to, and this is the residential piece. Go back to the next question. Go back to the unitized envelope. Go back to that. Go back next to okay. So this one we done it in Microsoft 10 years back. Normally, pergola everybody knows that the building will come on the top of the building. You need to go for IPO takeoff. So here it's a challenging that why we cannot do the unitized pergola. So where we come up with the unitized pergola design, we fabricate everything at factory. We come up just need to be installed on the factory. Like a sunshade. But we go for the 5 meter, 6 meter cantilever. We using that with the steel plus with the aluminum work, and we form that whole pergola, so unitize. We just bring it up and it up both. This we done it in Microsoft phase 1, phase 2, phase 4, 3 phases. We done it there, all we using for the design. Go back to PDD. Recently, we are doing this project for the project PDD. Trade tower. This was every 10th floor will be the building you see. You go for the corner balcony. So we started steel building. Sorry, steel building. You can say that it's a steel and
Composite.
composite building. So So this person is a fully steel, she's right. He's fully steel.
He's only still
JSW done under portion, but part of full steel, part of the building. So this building is a similar manner of a column, all projected column for 1 meter. All these columns with special LED lights. And now we come to the continuation of the topmost floor we discussed. Now the LED works are going on. This is the challenge for them. Every 7 to 10 floors will be stepping, and every 7 and 10 floors there will be stepping. To come to the roof level, it's only for being off of the building. It reduces to the top. The challenging here will go for a system. How do we go for the insulation sequence? If we go this kind of a thing, monorail as well as for the floor plate, we are utilizing both. And here there is no mechanical things, it's only a capping type of connection. And using for the rotunda columns, we are using unitized columns. This is the column. Everything is formed. But with the steel and the granite. And I want to test that mine because I am a consultant to this in Mumbai. So, okay. This is the cable wall system. The cable wall system here, what will happen? In the country stage, myself and one of the company, we are in the same category for the negotiating the job. That time is the horizontal and vertical both people. It is knowing that. So when it comes to the cost cutting, they are asking to give the valuable options, then we can do the job. Suddenly we have an option that okay, we reducing all the horizontal member, we just introduce only a vertical element to tie back to take that as single string support. So if we use Mumbai airport, all the one is using for only single string from top to bottom, only a single string, and the glass itself will control the loads. Such a method we design. If you look at it, all this vertical member only as a string. Look at it here, this other area. All the vertical member only a stainless steel rod. We go for 38 mm, another 32 mm. Will be tightened from the top to bottom, and the glass element will come with the clamp. The clamp is controlling the load. If you look at this portion, the string is top to bottom, we need to pull up this total. And in between, if you look at it, this is a rope connector to transfer the glass load to be this portion. This is the portion. Clamp will be pulled, and the glass load will be transferred from the clamp. If you look at this portion, this is the clamp to hold the glass, and what will happen? This condition is the all-the corner. If you take out the all-the corner of the four-sided, mechanically I hold the glass. Mechanically I hold the glass and I transfer the load to the road. So there we got this job, and unfortunately I left from the company. I joined as a consultant for GVK to complete this job. This is the airport while we constructed that. This is the portion, the vestibule area. In this vestibule, we are using a gold SS stainless steel with a gold plated things. If you look at that, all the pattern. This is the steel area, the airport steel. The concept of Maya is a white peacock. That is the main concept. from the white peacock it came out. I hope it is for the presentation. Who did this? So is that? Contacted we are the area guys. We came out from the Padmas Lisa than East. Okay, I'm a technical manager, SOE.
Yes.
This is the peacock design. And that also everything is having a skylight. You look at that, there is a huge thing. And we done, my whole company, we done the skylight. And this is a GF for C.
Yeah.
GF. This is GF, because the outside is GF for C.
GF for C.
Cement, the outside is cement. Either is GF, GF for C. GF for C is the external living gas. This is for the normal. This is not that way, only the facade is that way. This is and this is the expansion line. This is the expansion line. Even though we done the building, all those things, so certain things you need to have an expansion line. So we designed the such manner this separate string, and in between we have an extrusion with the cascade. So it can be moved any direction, out, up, down, everything is considered. This is the motion. After this, every corner of glasses will be supported. This is a bulletproof glass. Sorry, bomb glass glass. Happened. The design is after this one, once anything has happened, the total cable wall will take the load of whatever it comes. Explosion, load, whatever it comes, this total string will go, but it will not come as a pieces from each side. So all the cable will take the load and come back to the wooden bush. That's why it's a bomb blast. If you look at this, this is the portion, the element. I think you got it recently that this winter only got admitted in suicide. Because of this material, it's around the floor piece. Okay. They would have killed it. Huh?
What is gold?
Sorry, sir?
What is gold?
Gold coated. Stainless steel gold coated. It's an expensive material, and unfortunately, client is not paid to the contractor not paid to the supplier. And 1 week back, the supplier came into the contractor office in suicide. And this company project manager now is in jail. Using gold. Sorry? Not paying money. See, what will happen? See, all the things are good. When you come out to the article, it comes here. Now what will happen? These are the things. If you look at it, each pattern will be the CNC and every member. We donate a very expensive thing, but the contractor will come up and just somehow blurry material, half of the price only GDK is supposed. And the guy will do the job and take it out, and they lost too much money. And because of the design. The pattern and color, see anything you want to, conclude with the design, you should be in the previous thing. This is a goal or anything, how much the product we design, you need to suitable for that design only to come. These are the peers, the particularities. So the BMU, what is mentioning that in the morning, for building maintenance unit, they are using a track to go for the whole building to maintain. Go back to the images. This portion will travel along with the motorized. It's 1.5 meter cantilever that will be close, it's not hitting the sunshade, move around the building. Mogli check, road test. No, sir. Still not. So the factory, when you go for the framing of 300 mm, we use a steel frame and the clamp for the connects. Clamp for the connects. And assemble in the factory, everything as a unit we supply to site. This is the pre-assemble. When you come to factory, they are using fabricated and kept for glass. Once the glass comes, then you need to come up with the aluminum. Okay, sir. Thank you.
Thank you. Thank you.
Who will want to do this? Any questions, sir?
Break for 10 minutes.
So the next section is the glass processing. My colleagues will come up with it. Glass processing. The beginning level.
See, I want to touch on this, this last topic, which normally people will forget this. Even Magesh also said, we have to go for testing, factory testing for the last process.
Glass processing.
We will go only to the subcontractor work, like with these unlimited factory only. So this one, they will not do this. This is done by suppliers. Not sales. Only supply the glass. The process is generally people will, even you mentioned you have to go for factory inspection for the last processor. These are more, yeah. So what are the tests I captured? What are the tests he has to do? I captured in
Reverse it from glass processing, like manufacture everything.
Yeah. Excuse me. Remy.
Yes. So these are the main elements for manufacturing of the glass.
Yeah. Like this, okay, already mentioned, right? Prashant. He's Prashant from BFP, is building facade training institutes. They're having Rajapal Institute. He's taking classes. He's lecturer now. They are conducting in the facade that particular college one session.
Tell me again what
Rajapal.
Building facade.
Actually, we choose that college. Actually, we Magesh, so 6 of us, we want to train the students. When we are in Singapore, we study NDC2 for facade. So when you come back to here, we don't have any courses like this. So we want to train the students. They can do themselves. They can train what is the glass, how to manufacture. Because if it goes wooden people, they know that I go for Asari, I taken out. On aluminum, there is no classes. And there is no processor, how we need to teach them. The company will work for 5 years, then only guy will come up as supervisor. But we train in the college itself in the final semester, taken as one semester only for facade. So we train glass, processing, and installation. We have supplied up 10 curtain walls. They can remove and reinstall, and like a mechanical student and civil student. Both of them elective subject is facade.
So basically, these are the 5 elements made for the glass production. So silica side, limestone, soda ash, dolomite, and glass. Glass is nothing but the base glasses after which glass is manufactured. They will be having some standard sizes of 2 meters. So the excess side will be cut and it will be broken into pieces, and that's called glass. So this is what the process which is going through from production to the installation. So this is, we'll say the furnace or kiln in which all the base materials will be put into it and it will be heated up to from 600 degrees Celsius to 800 degrees Celsius. And it will be going through a float bath. Float bath in nothing sense isn't like a roller in which the solid, the liquid will go through it, and then we have some specifications for that, like 6 mm, 8 mm. So the amount of liquid which will go through that float will have the temperature of 8 or 6 or 12, whichever the recommended is. Then it will go through the float bath, and this is called the cooling chamber, where it will be cooled like not rapidly or not very slowly. They will be having some specification for like the glass hanging off will be hanging. So they will be having some specification, and it will be controlled through the electronic control system over here. And this is called the cross furnace, where the glass will be cut down the required sizes, and it will be discussed to the students.
This is for the glass. I think they're saying coming.
Yeah, same going. And this is what we call cutting glass. Cutting glass is nothing. It is a normal glass that has come out of the cooling chamber.
Floor glass.
Floor glass. So these are the properties of the glass, and it can be available from 2 to 99 thickness. And these are the components and density. And low glass. Normally we are asking for situation for the most sunny areas, whereas like this. The thing is that we can see that the outside is too much hot, and we doesn't want the heat to come and have it in environment inside. So we are using this low emission glass, which is having a low coating on the surface. The thing is that we are using the low emission on the surface. But whereas in the other countries where they want the heat inside, they will be using the low emission on the second side of the glass. So that when the heat touches the glass and it will reflect back to the environment itself. So, another thing is, and then it will reflect back and continuous will consider. And finally, units are all inside the layer. This is tempered toughened glass. This is a process where the normal ambient gas is turned into tempered or toughened glass. This is a properties of the then heat temper. Temper is like normal like glass, but the difference between the glass is the way they grow. Things are for the heat system glass, if you grow, it will crack like a thing, or it will have a setup inside and it will go through the corners on the end of the thing, and it will have a crack like this glass glass. These are the cooling failure. These are heating coils through which they go. This is called toughened glass. So this is the glass, when it breaks into crystals. Because of this will be cooled rapidly.
Heat soaking for everything. Only the tempered glass they will go for heat soaking, right?
Yeah.
Only for tempered glass they should do that.
Heat soaking will need to be go for the full heat. Then sudden cooling is. This is a risk of, it will be low for more than 50% will get glass breakages.
This is what how the glass will be seen after the temperature. This is the honey and like say it's in the both things there. What is the temper will be broken mass, small piece of crystals.
Low heat can be done for all the glasses. So is it?
Only for coating.
Low heat coating nothing to do with the performance thing. Low heat coating is for the only for the weather performance thing. Property of the glass will not be changed. For anything for all as you can. That's what. Double low heat. Yeah. See, normally what will happen, low heat should not be exposed. Should not be made exposed surface of the low heat. It should be in the inside of the inside of the
It should be a BG.
No, what is that?
it's a coating.
Yeah, it's a coating.
It's like a electrode type of this.
This is called the laminate. Laminate will be either PV bridge here or EV here. Two types of it's more like a plastic which combines the two glass layers.
Recently that 3M is introducing that a special layer which should be as even the brake also will be act as a steel thing. It's a transparent, but it will be extended like a steel.
So this is all the process. On the first glass will go through the PV layer which is cut and it will be on the surface. And the second glass will
This
be
is what will
like
do
a
the
sandwich.
processor. Correct.
It will be like a sandwich and the how is overlaid. Then it will be when for here and nothing sense. We're keeping them behind some apples. So the pressure will be here. Then there will be a reform of cleaning. Rather this is a general rather two layers like the sandwich will get molten and the air bubbles from the inside will take out and it will be clear.
This is lamination, same like a layer. Yeah, most probably we know what the advantage is because when the glass breaks, the result falls off. So onto the layer, PV layer, and we can don't have to worry about pieces falling down. So this is DGU. This is the most commonly used for vision items because this is what the glass between these two glasses will be used. This one will be a normal glass, and second glass will be a performance glass. This is the low quarter, which as per the things approval which we take, we do this. And with two glasses which is having the spacer. This spacer is nothing but a beading made of aluminum. Inside they having a desiccant. The spacer bar. We are having a desiccant. Desiccant as object. It's like for the temperature to be changed, you will be having some moisture inside the glass. So if moisture is formed inside the glass, you will be having a clear visibility. So to suck the moisture inside, you will be having a desiccant, which will absorb the water content inside the glass. So the inside the water or no mist will be formed. And this is where the cylinder is applied to both sides of the spacer edge, and it will be like same like a sandwich, and will have Q for some time. Then you will be having a DQ glass. And this pattern glass, like what the gazebo what we have shown pattern glass, we can do in the way whichever patterns we want, the color or non color we have shown. This is printed glass. Same like pattern, this is different. Will be having different shape. This is a photoglass. Photoglass is a low water. It shouldn't have a contact with the human or anything. So it has to be clean so that if you have like a sandwich and the properties shouldn't have changed. So these are the effects in glass processing. So while the glass is processed, there are so many processes which you go through. Mainly through the rollers. They are going through rollers while the glass is going through. The roller having must have the equal space. Otherwise, one is less and one is more. The glass is still not full, and while going through, it can go a deformation like U curve. Like this is bulging on the upper side. That's the lower side. Distance. The edge of glass, if it's not even, and most of the rolls should be even. It shouldn't be too fast or it should be too slow. So otherwise, the corners of the glass tends to go up or go down. Coating burns.
These are the days. Coating burns are generally that happen in the process. If the process is not right there, you will see there is a kind of coating waves. So if you use the UV, there is PVP, the T, wave on T, there is in glass. Where you will see all the heat waves. The process is good, it will be minimized or there will be. So this is because of it will happen only in the processing defects.
So what I have shown in the previous thing, that the heat wave is coming here, it will be detected, and some energy is directly inside, and some will be absorbed.
This is called solar factor. Normally, the glass selection, solar factor is the
This is called the coating. Which the whichever thing you want. There are two types of coating. One is the on-in coating, and the second is soft on-in or soft coating, or offline or hard coating. On-in coating in the sense the coating will be commenced in the time of the manufacturing itself. In the float itself, there will be a coating. That's called on-in coating. The offline coating, once the glass comes out of the pallet, we can take it to a secondary plant and we can do it. In Singapore, they have both on-in and offline coating. This is the process. So this is what the float bar. From float bar itself, they will be having the controlled atmosphere. They will putting what are the elements which they want to put on the surface, they will be spraying and then it will be cool. Then you will be having a coated. This is called offline. It will be like a marathon stripping. It's nothing but you have neutron electron. It's like having a positive and negative which will attract and it will deposit the layer of coating on the glass surface. So that's all about the glass coating.
Break, 5 minutes. 5 minutes break. Thank you. On the visit, this will go. Then you will take it back. If you have any doubt, there is nothing. Yes, all the
No, nobody is not.
So these profiles are we have to send in our new product with our actual
This is only, you want to show that only you do
the profile will have
that this profile will have this is the header. You can't humanly this profile. You look at only in the section 8, this is the
extension.
you will come on the 6 meter.
Separate profile.
Separate profile.
You have to type another.
Yeah, one, if you look at here, 1, 2 is one profile. For example, if you check the male, you like this. Here the handsome and female, separate.
There is no profile, this profile.
Yes, you have to assemble. This is except essentially everything will get. This is a problem. That's what you need to do. You need to place the closing. Then you need to shift the material and assemble that with the closed.
To avoid time.
Avoid time, avoid the dust also is important.
No, if you want to earlier boom in the factory, get a great essence.
See, what will happen only for curing time, we have 32.
But the later category of people,
Yes, when you apply the silicon should not be very deep. And then you need to
there are two the one is during service.
This is only for what will be curing time will be there. It will be external right. Actually curing is taking 3 days. 24 hours you can shift the pan.
Yes.
You cannot load it.
Take time operation, taking it.
Okay, sir. Thank you.
What I wanted, what I was expecting from them was how we do yes, that is good for them. What all we have to do. We are not going to do we are going to be like they don't need to know anything. That's everybody will get all you see. What all you see. There's no education, there's no education. We don't need to prepare the thing. It's how we can buy it. What I was expecting, we will deliver now, I think these teachers will be different. So that we don't wait for their question, we can ask the same question to them. What is it? What comes to you? We have done it. Optimal pricing. Where is break of so what would be the optimal pricing? Okay. When you put the software, whether it's a video software, what is it? Yes. Learning objective. Otherwise, applicant objective. After you have done this course, what is expected improvement in your overall performance? ये तो प्रोसेस के लिए जिसमें जिसको क्रिएट करना No. I've sent you.
Give them the papers also.
Everybody has that notepad, no?
Notepad is there.
That's not it.
Okay. Okay. If you look into this, later you can fill up this. Okay.
No, sir, 2 minutes.
Which one? No, they cannot go after fill up. They can go. Not for them. Is anybody else on that? No? Only collect. Okay. Okay. Quickly, I will touch up the IDP, inspection test plan, which what are the testing is supposed to do in facade. This already circulated. Even I told our contract Amin also to add it in the contractor's code while making the contract. So automatically, so contractor will not escape. They will aware that what are the tests supposed to be done to ensure the quality of the total facade. So here, all I referred European standard. What are the tests supposed to be done for the DG glass? This will be done actually at the factory, the processing unit. These are the tests to be done. So we have to ensure. So we have to ensure that in the factory they are doing these kind of tests. So we have to insist the contractor to deploy one person at the factory. If it is either aluminum or if it is inverters, what is it? Innovators or whoever it is, they are supposed to deploy one person at the factory, the processing factory. No, I'm telling there is two things. One is that the contractor will do assembly. There is aluminum, it's coming from Boroka. There is a glass, raw material coming from State Government. They will do processing. Actually, you've seen that bath and all these things. They will do lamination. He will not do. It's not, none of the contractor will do this. Neither aluminum or not. It's a processing process. It's called a processor. They will do. Same women are also doing it, but normally people won't give it to them. There is Pondicherry. You have to find out who is the processor. In the processor, he only makes the lamination, he only makes that gasket around it, and two glass, is making it as a composite. Factory is supposed to deploy one contractor side, should be there in the factory. So we have two ways of doing. One is the testing, and also actually how many glass is manufacturing. Without glass, they cannot do anything. They need aluminum also transfer, they need also the glasses. Without these two things, you cannot execute, you cannot see, you will say panel will come, but unless you don't know the actual what is the status of the glass processor, you cannot do that. He will tell you live. So one person should be there, and our team, either QC or architect or site engineer, should visit at least monthly once to go to the factory and see that what is the status of it. You cannot control if you're missing this glass processing. No, if you're not manufacturing it, so you will not get the progress. So these are the tests I listed here. This will be done at the processing unit. We have to ensure that he is carrying out the test, having the record. I have given his here acceptance criteria also as per the code. Actually, wherever they refer the specifications, the facade area, they prepare the specifications. So they are the pioneer in facade. Before, so they have their own facade testing unit also, right? So as per their standard we do it. And relevant European code or standards. So in the BG we have to go for pin code, we have to see the coating scratch, oxidation, abrasion, butyl, should be done at BG glasses. Edge deletion. So edge deletion there should not be any silver line you will see on the edges. And how do they test? There will be always the contractor will argue. You have to keep it vertically and 3 meters away you have to see it. You cannot go nearby and see. That is a picture mentioned in the code. So all I will very clearly explain in this. I will circulate all of them. Earlier also I have circulated.
This edge deletion, how do you see it from 3 meters?
No, see it down. The above parameter, can you read it?
Can you read?
For 300 mm for edge deletion, not 300. Okay. So I very clearly specify. Please note of it and see that we are following this. So this will avoid any issues at later stage. And same for the SG also. What are the tests to be done? I have given what is the dimension plus or minus 2 mm is allowed. Scratch and work maximum is the 75 mm. Operation is not allowed.
75 mm.
And how many quantum of check also given? The scratch.
What is the meaning of scratch and mark?
There will see what happens. They will mark something like. So that it will be maximum allowed is. You will not find visible. You will not see it.
No, survey mark is allowed. The scratch is there.
See, you will not visible, but
No.
3 meter distance. If you see from 3 meters, you should not see it. Maximum 75 mm is allowed.
That means 75 mm scratch is allowed. What is the meaning?
Whether it's a width or
Yeah, what is the meaning of that?
Yeah, 75 mm. As per the code.
That means up to 3 inches scratch is allowed.
This is in my class, mental class, at 3 meter distance. See, what happens, when backside was doing no spattle class, there will be backside, there will be some kind of moss or something which is there. Even some, it will be more only, it will be visible more, otherwise you will not see this. Scratch means what? What is thickness you think?
Not the thickness, the length.
Length, okay, what is the thickness you think?
Maybe 1 mm.
You will not see it. I mean, so this is not code reference, it's not prepared by. Even this will be beyond only it will be visible. Something is beyond only it will be visible to you.
I have done practice for the third time.
No, it will be beyond only visible. People will generally the mark.
That means you say that you will start from about the 20 to
You will see it. 100% will see it. This is not code reference. So for the aluminum, for the extrusions, and also given what is the quantum of check.
Okay.
So this we have to refer to the aluminum, what are the test, MDC, all these things.
But I have mentioned that it's third party certificate also should be.
Yeah, it is. See, some of things, so there is a third party and powder coated extrusions, these are the tests we have to do. So that will aluminum mill finish I'm talking about. For mill finish, MDC is enough. If there is a powder coated, we have to test it. DFT thickness should be 65 to 80 micron. And the back bend, which is GSC. So per lot, as per the code, you have to check it. The powder coated sheets. The gasket also we have to check it. These are the tests. The sealant and the structural sealant, whatever they use it for the glass for making BG or no. So what are the tests being conducted?
frequency is there.
Yeah, frequency also there. For lot wise render, you do this. So they'll be maintaining. Actually, these things, Dow Corning is specified, and which will be using. I think Dow Corning, most probably Dow Corning will be using it. That person also will be there in the process unit. The Dow Corning person will be there. He will do the test. We said the butterfly test and all these things. He will be doing it. So if you go and ask this question, automatically they know that we know the things. So they will be doing it, maintaining the records. Otherwise, they will see. For the anchor fasteners, whatever the anchor we do in our sites. The pull-up test we have to do. minimum 4 locations per elevation, something like it. I think we had a problem below so how many years to do it and all. So minimum 4 per elevations. And torque test also yes. 100% is to do the torque test, the tightness. And the pad water that is using for that. Starter still, we have to see the water test and all these things. For the first starter still, he will make it whole and will put the sealant and all. So they will do the test. And given how much deviation in the plumb and all these things they given. And for the water penetration test, the loss well. So we have to do at least minimum 3 locations for each type of wall. Each type we have to do at least minimum for each elevations. We have to do that. This is what we are going to make it in the contract. Correct? So we have to incorporate in the contract these tests. So we will move on to Amra Tower, which I am working as a PPC manager from the foundation to the commissioning. So this also have a lot of facade also there. There is a BGU covered glass and also stone cladding. There is video also there. We will quickly run to it's 40 minutes, but we will not get into that. Maybe relevant part only we will select it. So this is the tower, listed tower in 412 meters height. So this is the L&W Workshop. So there is L&W real estate, they are the client. The design is SYM. Speak more. He is the Dubai also, he is the designer. The local consultant is and PMC is the Ramner Construction. So main part is the America, so where I go. So they started the building in 2005 and completed in 2011. It's the world tallest sculpture building. Sculpture means that shape. And it's the tallest building in Dubai. Actually, it is a non-symmetrical structure. It is not a symmetrical like Burj, you see, it goes like a symmetrical. So this is not a non-symmetrical. It's actually twisted. That the walls has been rotated. You see it, and it is 412 meters, 77 story, basement 3 basements and 74. You see the height 412 meters. We calculate 300 plus, but there is a lot of it is around 1 lakh square meters. So there are flare walls which will change the position. This is an alternative which I am talking about. So it's a both cost institute price 300 members, 1200 diameter. So design load is around 60,000 to 27,000 meters. The foundation concrete is C50, the raft concrete. Reinforcement used grade 4 meter, higher grade. The raft, the bottom raft around 4 meter depth. This is a guide. This is the raft. The 4-wall thickness is 1,200 to 600 mm. It's a composite column. The steel up to the 429 steel and surrounding with the concrete. Then higher level, it's only the concrete. We used this steel, grade 24.5, reinforcement grade 4 mm. So we used prefabricated gauge. Prefabricated just lifted and put even for all walls and everything. So you'll ask the question, the lab will come in all the one locations. So there are special approval for it as well. So this allows yes, normally people do like that. Sorry? Yes, but here what happens, they will ask why the lab is coming in one location. Then people will ask for it. So it is done. So concrete, we use self-constructed concrete. So it's up to 80 shear wall is done. The retaining walls are catheter protected because of the nature of the building. We was doing the cathodic protection. Cathodic protection, what happens? Yeah. So what happens? They will run positive, positive and negative anode. It will monitor always the current will pass in that anode, so that reinforcement will not get rust. So generally, here in India, they use for the pipelines, oil, gas pipelines, and all. They will use this cathodic protection. So the pipeline which is buried below the ground, it will not get rusted. Otherwise, it will have a hole or it will blast.
There is like electrons is continuously.
Yeah, electrons is continuously. There is two layers. They will put one and get. Always there will be current will be passed, so we won't get rusted. And we use lightweight hollow block purifier. Its core wall is 12 to 14 days. It's a very formal system. The slab is done 11 days. It's 4.6 meters height. Well, initially they got delayed and later on they got that. So this correction in vertical means the core wall, it will actually what it will settle. So 300 mm it will settle actually. It's designed for 300 mm settlement. Once you start, then it goes up. Once you construct it, it's gone 300 mm.
So it will punch the art.
Sorry, I have to say.
Then it starts to punch the art.
No. There is columns, then raft, right? The whole it will settle.
Including the art.
Yeah. This one design. And it's monitored also. So, see here, this is the 300 mm is different overall settlement. So, what we do whenever we cast, we will cast little higher. 100 mm higher. If you see this level, 120 mm higher we cast, it automatically goes down. But the periphery columns are 65 mm only. So, then if you see the level, it will be 150 mm here, it will be 65, 365 only higher. Then later on, this core will settle. It will come to same level. And also, not only settlement is torsional because of the shape. There is clockwise also, there is a change. Corrected torsion will be done. It's not exactly the same coordinate in everything. It will be changed. So this is shear wall. See, this wall is here, and this side wall is here. Once it goes up, the finally it comes like this. This wall, which is horizontal, 90 degrees shifted that wall. So it's like overhang. So this wall in the lower level is like this, horizontal. Then once it comes up, the top level is like this. Same this direction also. So concrete on 1 lakh cubic of concrete is used. Reinforcement upon 60,000 tons of steel reinforcement is used. Structural steel 6,000 metric. This is the front side elevation. Reception area, so 24 meters. This is all we precast and we lift it up and connect it and put the concrete in the joint. And also this column, it's not only sliding, it's also curve also. The front side is the reception front side, 24 meters height.
All steel.
Steel column. So the stone cladding is around this side, you see the openings, right? So this is not stone cladding, and this flare walls, they just leave with truncates and tandem legs. Other sides are glass. Glass on 16,000 square meters, and also we have curved glass. Wherever this turning, right? This turning is a curved glass. This 1.5 meters the. We have 40 elevators, 10 meters per second speed. This is the front edge, the entrance. So because of SOM, we monitor the strain gauge. So we fix the strain gauge in all columns to see the settlement and everything, the rotational. So we have to make report every month and send it to the designer. So you will keep the strain gauge inside the piling and also inside collar. So this will be connected to the computer. It will give the reading how much it is paying.
Okay, data will be transferred.
Sorry,
Data will be transferred.
no, there is a system. It will be there will be the data logger. From the logger, it will be wire. There is a wire to the system. From there, it will download. And also that height, that also they measure. It's called digital tape extensometer. This is 0.01 mm. It will measure up to 0.01 mm. And the verticality is done with the GPRS. Here there is surrounding 4 buildings. They located the satellite with GPRS. From that, every day we check it with the 4. Combining will make it for the alignment for the coordination. We call from Korean engineer. Use the antenna will fix it all the 4 surrounding higher buildings. Yes. There is a penny system, same like tracking model. We are doing it.
Self-driving system.
Huh?
Sleep.
Tower crane is there is 2 tower crane at the top. So there is the room placer to go. Caricos will make 2 pipeline for concrete and 2 complaints. So we will see the video.
3 level.
Core will go 3 floors higher. So side, you have seen before. The side will come 3 level below side walls.
So tower crane.
Tower cranes in the center of the core. 2 will go to the right.
Along with the former.
Yeah. They will cross further, they will put some kind of you go along with the core one. They will shift it.
So material will come from down.
Yeah, from down they will lift it. You can see that.
Also, the activities are taken the color only inside.
Sorry.
So these material lifting and activities are taken from the
Not from the core, outside. Once the two goes. No, then the video will see. For the facade, we have a platform. Then from there they will take it to floor, then from there with the program they have to start. So there is a Chinese company they did it very fast.
Concrete SCC or
Yeah, SCC.
all SCC?
So this is no building figure, they have
Alabama will be taller than the Empire State Building. Now there's another 9 or with 2 great
I'm gonna
want it. And that's actually happening to this building, right? Covered in over 2,000 tons of limestone, making it one of the tallest stone-clad structures in the world. And topping it all off, a 17-story restaurant that's one of the highest ever built. Of all the times I've heard of demo down, this is the one I'm really serious about. Good morning. Be ready to begin a new chapter in their history. And to signal that to the world, they're about to build an enormous piece of architecture. The Al Tower. At 1,350 feet, it is the tallest building in Kuwait, a skyscraper like none other in the world, with 2 one-of-a-kind walls flaring out 150 feet in opposite directions. Whose revolutionary curved glass facade makes a massive screaming turn. And at the top, a 200-foot enormous open space that will house a restaurant like none other. So I built this tower about the decision to select this design for the tower. We based the choice on putting Kuwait on the skyscraper space, creating a new icon for Kuwait City. This will not only add to Kuwait, but it will add to the international community of skyscrapers. The tower will stand unique and special among all its peers in terms of skyscrapers. To stay unique means engineering the previously impossible, namely the 2 flaring walls that define the highest twisting tower in the world. So those 2 flaring walls as the building rises up. The east side comes in, right, while the west side pushes out. Absolutely. And what does that do to the building? No, that puts an extra weight on the wall that's pulling out. So it's if I were holding my dumbbell, right, and I pull one arm in and put one arm out, I'm going to want it exactly to fall over that. Exactly. So what you do? Well, what you're doing right now is actually building in an opposite twist. So when we cast our concrete, we cast it with an opposite twist. Because of its weight and gravitational forces, the concrete in a skyscraper compresses or creeps over time. In rectangular buildings, this happens vertically. Knowing this, engineers build a structure a few inches higher so it settles to the right height. And Alhambra, it creeps not only vertically, but its twisting shape also causes it to creep horizontally counterclockwise. To correct this, they're building each floor an extra fraction of an inch clockwise from where it had done. So when it settles, it'll be perfectly straight. So you're actually building the building counter-cranked in the opposite direction, right, with the knowledge that concrete will creep over time, right, and straighten itself out. Absolutely. Building in the right shape isn't the only challenge. The entire skyscraper is built with concrete, almost 500,000 tons of it. And engineers need to deliver that concrete a quarter of a mile in the air. Now, this is the concrete coming out. It's unexpected for the water, but that's actually okay. This concrete is really amazing. It's simultaneously incredibly strong. But also, this is enough to travel as far as it's going into. Using high-powered pumps, the extra-strength concrete can travel over 1,200 vertical feet in less than 15 minutes. Any longer than that, the concrete will cure and lose some of its strength before reaching the top. So now the concrete is finding the hopper, or the elevator, move the concrete up and pour it, and it will be the highest flare we've done thus far. Really nice, all the way down from there. So with ancient roots that we push it back, you can feel the concrete push this thing back and forth. And the issue has been bust out. We pouring concrete either inside the tower or straight over the edge. Here it comes. It's coming out of 1,200 feet in the air to fill this What is going on here? And the concrete is coming into the formwork. The man behind it is migrating the concrete, aerating it, giving a couple of times. And all this has to get done for the next concrete structure lines. With the first truck empty, they have 2 more to go in order to complete this 15-foot section of the wall. In 7 weeks, this amazing coastal wall will be finished. The Alhambra Tower will be unlike any other skyscraper ever built. And it's going to see many features without a doubt. My name is Danny Forster. The tallest tower in all of Kuwait. Coming up. That's what I'm hearing, son. Absorb that solar radiation. Limestone is an effective building material in the Middle East. It can sustain dramatic shifts in temperature without cracking. The panels that will cover the south wall are massive, measuring 4 inches thick and weighing over 200 pounds.
The stone bracket, which I talked about, the full height of the stone.
Now the stars over here, we have to get it on the outside of the building. Nice and tight. You can imagine what happens when the southern sun hits the stone. The little absorb that solar radiation and keeps the entire inside of the building cool all day. It's not just the stone, but the configuration of the windows that protect the building from the sun. Their standard pattern to angle the sun, block direct light, and reduce the exposure of the sun. On the frame on which you're hanging stone panels is important to keep stones vertical, but also horizontally lined up as well. Yeah, but vertical, so when they also do the same line, then we'll make 10mm gap between every panel, running all along the side facade all the way to the bottom. So this gap allows for heat expansion, so the panels don't collide and buckle in extreme temperatures. So now the piece is more or less in place. The sort of fussy adjustments begin. A millimeter here, a millimeter there to make sure this piece lines up with this piece. The piece below. Layered walls be covered in limestone as well. But their twisting shape presented a problem. Had they taken a regular piece of limestone and tried to apply to this curve, it wouldn't have fit, because limestone wants to go on a flat surface, and this thing is twisting. To maintain the seamless monolithic look architects wanted, builders proposed a material never used on a skyscraper. The solution is something really amazing called truncatus, which is essentially a piece of limestone, 1 inch thick, shattered, and made into a series of small shards. Those individual shards then glued to this mesh. What's great about it is, number one, it's 1/5 the weight of that big chunk of limestone. But even more importantly, look what it can do. I can bend this mesh in pretty much any direction I want. The challenge, however, is getting this piece of truncatus onto a concrete wall all the way up there. to perform one of the highest tiling jobs ever attempted, he's taking a precarious trip. Because unlike the south wall, whose windows provide easy access to installers, the opaque flare walls have no access. All the way perched on top of the skyscraper, kick out over the edge of the tower crane. And the tower crane is a cable, and that cable has reached me in one corner of this bucket. And this is my chariot ride up. All right, fellas. What's that? Just hanging in a bucket for my buddies. Got one to my left. I have looked it over. Batman. Yeah. And Ron. This is the take of Take Crusaders. We fight crime, but instead of crime, we go to buildings and we apply stone. It's similar to what Super Friends used to do, right, guys? Yeah. Yeah. There it is, the Super Friends. Good night. Oh, yeah. That's a perfect sound. We're only halfway to our final destination. That gondola perched over 1,000 feet in the air. Of all the times I've heard don't look down, this is the one I'm really serious about. When you look down, you're going to see the geometry of this wall just twist away into nothing. Just want to go through. And that's the only thing goes like that. The crane is now sliding us against the building. Almost there. Almost there. Okay. I'm going to make a couple more safety on the line. I don't let that big, and I went to the gondola. There were 28 Trump-House teams that covered 2,200 square feet per day. It'll take them 5 months to cover both twisted walls. Okay, so here is the thread wall. Yeah. This is the most twisting part of the wall. Yeah. And here we must put the Trump House. Yeah. So this is check whether the thickness is along the slash. After it got layer, then we have to fix it. So we make sure and do that. So we confirm that we have the right depth of the adhesive. Yes. Okay, let's do it. I guess I'm 15 years to cover this facade. This is basically like extreme bathroom time. There's a lot of guys who do great tile work out there, really overtime right now, but given the circumstances, I apologize. Imagine for a minute if this were one solid, straight tile of limestone, right? You would do this with heavy and actually pull on the side of the building. So what makes this so great is that they're made with little lines that are combined with different. And the flare wall has been covered with 4-inch limestone. The load would be about 2,500 tons of this innovative solution. The total weight is reduced over time. Okay, so now I'm at the very last slide that just went forward. And if you look over there, top the way up here. The next step is to get it up and over and inside the center board building. So they can come up and over. Yeah. And we'll fix it on that in this place. And it's this steel structure right here that will extend out all the way to the edge of the building. Yes. To support this 17-story open space. making it wider at the bottom and narrower at the top. Alhambra went a step further, twisting the entire facade, thereby not allowing the wind to organize and dramatically reducing the sway. So the seemingly strange asymmetrical shape of the building actually. So if the south side of the building is wrapped in stone, the north side of the building is wrapped in 11,000 panels of this amazing glass. Wrapping curves in glass is difficult. Most skyscrapers use a technique called fastening. Small front panels are aligned along the curve, but this only creates the illusion of a curve and not the real thing. At Alhambra, because the north face curves at such a large radius, they're able to do something that's rarely done. Here, you've actually curved the glass itself.
Yes, it's a curve with glass itself, but due to the curvature, big radius, you can curve it the glass. For a small curve, you cannot. This is good. We have good chance because this is a big curvature, so we made it a curve.
To generate the gentle curve, 1/3 of the 11,000 panels have an 8-degree bend. And these panels are delivered daily to the installation floor via the tower crane. They come in 2 sections because of 3 tons, 6 panels are just too heavy to move altogether. You know, one of those dusted wheels like in supermarket that goes like this. So the glass panel now goes to a crane. The rest slide the copy into position. Put it up into the hoist. I don't really push this piece of glass outside the tower. Okay, here, good. Oh, yeah. Over here. Yeah, that's over here, fellas. That's fine. Fellas. Crews have to be careful when pushing that, because the surface is covered in a layer of silver oxide that gives the glass its reflective look, but also blocks solar radiation. What's it up? Oh my goodness. Put it back road. So slowly easing it out. And so, right there. So the panel's now down. The one obvious problem is the panel is looking in at us, right? This is the facade of the building. So we have to flip it. You can see it in the mirror all the time. You can see that curve. Keep it tight. Oh, look at that. As I tighten this last screw in, you're going to see what I mean about this being a real curve of the building. Look at this thing. One smooth, long, beautiful line. And you can imagine why. Sitting in your office, looking out from this glass at that. This building is made for this site. Installers use 100 panels per floor to cover Alhambra's curved facade. But the challenge comes when the glass panels have to join with the twisting. Wall of the building. And primarily fills the gap. Aluminum flashing is used to fill the gap, drawing a thin line at the curve of the wall, blending old world stone into modern sweet glass. Hello. I'm Danny. Yeah. How are you? Fine, thank you. What's your name? My name is Smith. Yes. Have you looked down there, sir? There's nothing there. Yeah, so there's a little string that we look up, no?
This is a flashing.
At the end of the scene, something blew up. Will Smith got the grill. Mark Lawrence made a couple of jokes, but in the end, this piece of flashing is lined up. The glass is met the concrete, and this amazing twist is now rendered in steel. Smith, I love you, baby. I love you. Coming up, getting people a quarter of a mile above Kuwait with one of the largest and fastest elevated motors in.
Any questions or anything, something you can ask for it. How are you? We will go for small things. You nail the question first. Need the question.
Need the questions. Need the answers, yes. They know the question.